Hoffman.
Hey friends, I'm Nikolai.
Hi, I'm Mustafa Turaman.
Hi, I'm Tanya Janka.
Hello.
And I'm excited to be the speaker at Azure Summit 2021.
It's a fantastic event that will be 11 days live streaming,
Where more than 100 speakers from all over the world.
I'm excited to speak at Azure Summit about Power BI and Synapse Analytics.
And I'm going to talk about security.
And also a Microsoft MVP for Azure.
I'm speaking at Cloud Summit about automated release of .NET application.
And the best part is that this is a free event.
Come join me live at Learn TV on September 17th.
Come join me live on Learn TV on September 14th.
Come join me on Learn TV on the 14th of September this year.
A bunch of other Microsoft and community speakers.
So if you want to learn how to secure Azure, come to my talk.
join us. It will be a lot of fun.
See you there.
See you there.
See you there.
See you there.
All right, welcome everyone to day 3 of Cloud Summit 2021. I'm your host, Stephen Simon, and welcome back. What an absolutely amazing first 2 days we have had at this event, reaching more than 40,000 unique audiences across all our platform. And when I say all our platform, we are streaming this Cloud Summit 2021 at Azure Summit.live website. We are streaming on Learn TV. We are streaming on Microsoft Developers YouTube channel and a bunch of more destinations. So for people who are joining us for the very first time, this is Cloud Summit 2021 focused just on Azure with over 150 speakers and 113 sessions. There is 11 days of live streaming just focused on Azure. You'll get to learn the entire ecosystem of Azure, from the people who are building Azure to the people who are working on Azure, and from the people who are actually learning Azure. So I'm really excited for this day 3 part 1. So as always, I've been looking in the comments from past 2 days. You all have been very kind to each other, and that's what I expect to be continued. Please be kind to everyone. Follow the code of conduct. And yeah, having said that, when it comes to the comment section, so we always have a contest going on. So there are usually 3 contests. The first contest is the live comment contest. So whenever you drop any question to the speaker or share your thoughts in the comment, please use #CloudSummit hashtag, and towards the end of the day, also towards the end of the this first part, we're gonna pick the winners. Also, we have the contest going on Twitter and on LinkedIn. So take a screen grab or take a selfie of you watching this Cloud Summit. Tag us at Cloud Summit Live. Use the hashtag Cloud Summit and tag us both on LinkedIn and on Twitter, and we will pick winners from both the destinations. So again, welcome back. This is day 3, September 15 of Cloud Summit 2021. And having said that, I'm really excited for the very first session of the day, because it's going to be on Azure Custom Vision. The other day we had Prashant talking about the entire ecosystem of Microsoft Azure AI and machine learning, cognitive services. And today we have Ambarish, who's going to talk about bees health detection using Azure Custom Vision Services. I personally love Azure Custom Cognitive Services, the entire package that they have, and that you don't have to be a very hardcore developer to go and get started. So without any further ado, let's invite our very first speaker of the day, Ambarish, who's a NASA citizen scientist, TCS Data and Analytics Practice Lead. So let's welcome our very first speaker of the day 3, Cloud Summit 2021. Welcome, Ambarish. Welcome to the Cloud Summit 2021.
Yes, thank you so much. Thank you so much for for allowing me to participate in it. It is a very fascinating event. So, without further ado, let me start my session. So, this is about a very interesting thing. This is about these things detection using Azure Custom Vision Services. So, let's jump in and I'll give the motivation behind it. So what is the motivation of doing this? We might know that every third bite of food relies on pollination, but honey hive bee losses are quite prevalent due to disease. But the indication of hive strength, what is the health of the bees, is very time consuming and disruptive to the bees' workflow and hive in general. So, by investigating the bees that leave the hive, we gain a more complete understanding of the hive itself. For example, an unhealthy hive infected with the varroa mites will have bees with deformed wings or mites on their backs. These characteristics can be observed without opening the hive. So, that is the motivation. So it is an ecological problem, and we are trying to solve it through image classification. So what are we trying to do? We are aiming to detect healthy and various types of disease and ant problems, the varroa and hive diseases with the help of Azure Computer Vision Service. So where do I find the data? The data, what we have done is that I have taken a data set which is from Tangle, and I have made a very small data set of it. So these are the links that are there, and we can go into the Tangle link as well. If you just use this. So if I go into this, so this is the actual data set. It is quite large. It is around 54.74 MB. But what I have done is that I've gone ahead and made every data set, which is a subset of that. It is all in Kaggle. It is free, so you can download it and see it. So intention is to detect healthy and various types of diseases. So what are the steps? So I'll just give you the steps here, and then we walk through the example and how we have done it. So first is we create a custom vision resource. And then we create a custom vision AI project, and then we add images to the project, and we train on the images and create a model. So these are only factual things. What we do is that we go into the Azure and we'll see. So this is we are in customvision.ai. So I have already done the projects myself because training takes a lot of time. But if you're going to do it yourself, so that's actually very easy. You can do a create project. You can say these. Since I've got a these project, maybe these two. These add some description. And you create the resource. So here you can create one resource, whatever resource you want, you can create one resource, you can choose your subscription, you can choose your resource to. This is cognitive services, it's a location and a pricing. So this is how you would create a resource. And then what you would do is that you would choose a project type, whether it's a classification or an object detection. So in this case, since we are classifying the bees, we should be choosing classification and not object detection. Here, we will be choosing the classification type. So you can go here and see what is the meaning of it. But basically what it means that for one image, there is only a single label. It is not a multi-level problem. Meaning, if it is an AND problem having some AND problems, then it is an image of AND problems. If it is an image of, say, narrow high bytes, then it is an image of. If it is healthy, it is healthy. So it is a single tag for image. And there are certain domains here, we make it general, and then we can create a project. I will not do it because I have already done this project, and so this is the project out here. So what are we doing is that then what we do is that we add images. So how we add images, I have already added the images, but I'll show you of how you can add images. You can add these images by say, going to add images, you can go to here, maybe say suppose I'm doing this healthy and problems. So I'll choose here, I'll say open, and then what I'll do is that I'll add my tag. So here I'm choosing the images and I'm putting a tag and then I'll upload the images. So what would happen, you see here I've already done this because the training and the uploading takes time. So I have AND problems, which is have all these that I have uploaded out. Similarly, I have uploaded some LDBs. So these are the LDBs which are down here. Similarly, I have arrow height features, which are here. So it is a key class problem. So there are 3 types of labels here. And after I have done, what I do is that I go ahead and train this. So training, I can choose quick training. So this trains the image and it takes a lot of time. So I've already done it. So it's already trained. So the training, what will happen is that, so as Sam was saying, so this is a great thing. So previously, if you were a researcher or a deep learning data scientist, what would happen is that you have to write all these algorithms, all these models like ResNet, EfficientNet, and all these complicated models. You have to understand the structure, but here you do not have to do anything. Just you have to know your domain. So the domain here was these. You have to know the label. Somebody will label it for you. So if you're a domain expert, this is great. So it helps you that once you label it properly, so now it is these that we are talking. You can talk about more serious problem like, say suppose if you're in a manufacturing industry or an utilities industry, you will have some, say, rods or assets where there are some cracks. You can do these type of things. You can label it some having some crack type 1, crack type 2, crack type 3, and you can differentiate between them. So that becomes very easy. So for a domain expert, it's a great thing that you see. And then you train it. Once you train it, it's already trained, and then you can do quick tests. So what would happen is that after it has trained, it would use this model so that you can use it for training, for testing. So what I do is that I browse to a local file out here. So here I have, so suppose I test it. So I choose this image and I go here and I see the tags which is coming up. So it says that it's a narrow high V2 and it's a healthy and problem. So actually it's giving that this one is the one, it's a narrow high V2. But to know whether we have done it correctly or not, so what we'll do is that we'll see the actual data. So what did we choose? We chose this guy, so it is 040314. So I have the data actually with me from the data set 040314. So if I just do a filter, 040314. Okay. So it is a narrow high V2. So it is giving like this narrow high V2. So this is the one. So it is doing it correctly. So we will see of how we can do. So this is from the E1. So what would happen if I try to use it in a program? So what would happen is that this is a project out here. And then what I will do is that I will go to the project and there is a project ID out here. So this is important, and this is the project ID is important, the key is important, and endpoint is important. Now, once I have trained, so say suppose now you have spent a lot of time in labeling and you have trained the model. Now, what you do is that you want to use it in your own application. So what I did was that I am using this endpoint which is there and the key, and I'm using the project ID as an API in an external program. So what I did was that I went around and created an application, a Node.js application. So here there is a blog also I've written for this. I'll share all these links with you. So here what I have done is that I've created a Node application. So this Node application I've created, and it is installing. We will install all these libraries, the cognitive services, custom vision training, the cognitive services, custom vision prediction. And then we import these libraries, and then we have the training API, the prediction API, and then we have the route where the data is kept. We have the prediction key, endpoint, the iteration name, and the project ID. Note what is important: prediction key, endpoint, and the project ID. Otherwise, all these things are all standard things, but what will be unique is this. So this is required for predicting and for authentication. So once, and you can get all these things in your from your project. So project ID, key, and endpoint. So I went around and did all these things. All the code is here. So then what I do is that I pass on an image like 040314. Or I can pass in 030471 also. 471, 030471, 030. And what would happen is that I'm going to use this for predicting. So if you see, these things are for prediction, and this is the data that I am passing in, and I am using it for predicting. And then I am using it as to calculate the probability. So if I just run it, so if I say this, so it is giving AND problems. So this this thing over here, 030471, it is having AND problem. Let's see whether we have done it correctly. If I go into this side, 030471. You see, it is AND problems. So I have predicted it correctly. It is showing me AND problems here. So this is how, in a very simple way, if you're a domain expert, you can train it, and then you can give it to the developers. And if even if you're a developer, also you can do it if you have some amount of domain knowledge for labeling and for doing all these things. So it is very, very seamless and easy to solve very complex problems and to solve very problems that is affecting the world with Azure Custom Vision Service. So that was the whole intention of showing this demo. So I'll see if there are any questions.
So are we done with the presentation, Ambarish?
Yes.
Okay, that's great. So that was great. I mean, you're uploading some pictures on the Azure Cognitive Services, right? Then not even writing a single line of code, and then just training it. A quick question. I mean, how many ideally pictures I should add to train my model so that it works?
Yes, that's a great question. That's a great question. Usually, people they say that it's around 50, but I would say load as many as possible. And put it what they say is that which is very correct. So if you have an object in one position, you try to have object in another position, so that you have a lot of variation in the image, so that it helps the training much more easier.
Okay.
So say suppose example, you have a dog and you have the dog facing towards the right, so that's one image. Preferably, you should not have the same dog picture 1,000 times. Rather, you should have some other dog which is facing to the left. So that data variation, if it is there, that would be. So 50 is the minimum. I have loaded 100, and that's about it. So it was a great thing. So another thing that I did, I used it for eye images, for eye images to detect retina problems, diabetic retinopathy. It is not that great because you have to do some pre-processing before you load the images.
All right.
So,
yeah, go ahead.
Yeah. So, yes. So why sometimes that image what we are giving it to them, the model cannot really do it perfectly. So what happens is that if you do some pre-processing and do those things, then the model is able to do it properly. Ultimately, under the hood, what it is doing, it is using some deep learning models. So if you are a data scientist or a deep learning researcher, if you suppose you didn't have these type of wonderful services, you have to code it yourself. So that's how it's being under the hood. And for a deep learning image, input should be very good. Here the input was great, and we got around, say, that's a great thing that I can show you. Here, here the predictions on these images, performance on these images was around 100. You won't get 100% actually. So this was great, but usually it's not like that. So you have to do some more pre-processing on these images. But this was a great set of images, and we ran all these code, and it turned out very nice and gave very good results. So it was, when we ran it with ant problems, it gave me a 97%, and actually it was 97%. So how we can use it in practice is that is you bring in quality images, and then you will get better results. I see there is one good question. The more data set quality, the more best results. Yes. Is there any possibility of wrong conclusion? Yes, absolutely. Because certain times what would happen, the model may not be able to do it properly. And then what you would do is that, so this is something which is very custom. Then what you would do is that this custom vision service is not helping you out. So what you will do is that you will code on your own. You will do a lot of pre-processing. You will fire up your Python SDK, and then you will write your own code, and you will deploy Azure in it and put it in production. So this is the very first step. So if you're approaching a problem, this might be a great step. It works out, it's fine, and it is a person who is a developer but does not have a lot of deep learning, machine learning experience. It becomes easy for them. But if suppose it's very custom, it's not really typing out, then you go for something hand coding with Python.
All right, that definitely makes sense. That was very detailed. I think you took it. The question from the comments. I have a couple of questions, Ambarish. We still have 5 minutes before we move to the next session. The very first one is the computation, right? Do I need to actually go ahead and create a computation dedicatedly before I start it,
No.
or I get it from the cognitive service? How does that work?
Yes. Cognitive services is doing it on its own. So that's a great thing. So that you are, meaning you don't have to do anything. So that's it.
Okay.
So very frictionless. It's very developer friendly.
Yeah, that is right. So I don't have to worry about the computation, the all the hardwares and all, right? What are the
We don't have
specifications
to
I
do
need?
anything.
Uh,
Yes.
that's perfect. Also, quick question, Ambarish. Now, once I've trained my machine learning model, right, I figure out that hey, it is working fine, but maybe I need to add some more. Maybe I've got some new version of these, right? So maybe I need to upgrade my machine learning
Yes.
model. So do I
Yes.
have to again go back and upload the pictures and retrain my entire machine
Yes.
learning model, or if there's any
Yes.
other way out?
Yes, I think that's the way to do. Is that you go ahead and add those images, and I will see the more variety of images you put,
Hmm.
the more your model would be there, and you retrain it once more. So that's great. So and then you get another version of the model, and then you
Hmm.
use that model to use in the API and in your application.
All right, that's great. So you're telling me once the machine learning model is trained, I get these endpoints like APIs, and I can use it
Yes.
in any of the
Yes.
other application that I have. May it be a web application, a mobile application, maybe I think Power Platform. I think in Power Platform ecosystem they already have inbuilt this cognitive services, right?
Might
So
be. I do not know
yeah,
whether it does, but
yeah.
for you is and for a developer it doesn't matter. It's a REST endpoint, so anybody
Mhm.
can use it. It can be from a Go application, it can be from a Python, it can be Java, it can be
Mhm.
even this. You can do it from CRM also, right? Microsoft CRM or Microsoft Biz
Yeah.
apps. So that's great actually.
That's
And
amazing. That's amazing. I think it is something that people should definitely go and check it out. So, Ambarish, quick question before it's now. Suppose I don't have an Azure subscription, right? And I want to
hmm.
go ahead and use the cognitive services. I'm not a Microsoft partner. I'm not a Microsoft MVP. My company is not having this Azure subscription. Is there any way I can go and get started with some free subscription or tiers?
Yes, absolutely. And actually, you know what? That was my position. I did not. I am not. In, now I am having some subscription, but previously I did not have anything. So it's
Mm-hmm.
actually, Azure is that part is free. Somehow I'm using this subscription. It is not allowing me to do that zero free tier. So there is a
Mm-hmm.
free tier there. So if you have a pay as you go or a free subscription, please go ahead and try it. It is a free tier and it doesn't cost much, even if you are trying out maybe pay as you go. So I would suggest that if you have some fun pictures, say Simpsons data set, like Simpsons, all these characters. So you can take from Kaggle and you upload it. It's maybe 100 pictures and all these things, and then you on your own can do a machine learning application and create a cool web app and expose it and you can brag about it. Or you can do something more interesting like some say I would say cracks in metal, cracks in say pipes, which is like a
Mm-hmm.
manufacturing utilities kind of thing. Right? You can try that and see without employing data scientists, senior data scientists, and all these fancy maths, can that solve? Maybe it might solve. So your innovation capability increases. This, as your cognitive services, it's an ability to innovate at a great length. So that was amazing.
All right, so that's perfect, Ambarish. I think you did answer my question that hey, there's some free tiers. Go ahead and get started with this free subscription that Azure provides. I think it's for I just checked it. I think it's for 30 days, right? So it should be good enough for you and your team to
Yes, yes.
to test it and understand whether you should go for it or not. Ideally, you would go for it once you try it after looking at your session. So that was an absolutely amazing session, Ambarish, on Azure Custom Vision Service. Any final thing you want to plug in before we move to the next session?
Yes, so there is a blog out here. I don't know where I can put in the comments. Maybe I'll put into
You can give in the
in the
private chat.
private
That'll be
chat,
great.
private
Yeah.
chat, and this is the blog out here. And the great thing was that this blog post won one of the blogging contests of Azure, so people liked it, and it is very detailed. It has got the source code, it has got the step by step of how I did it. So if and it has got the public data set also. So please go ahead and try it on your own. That is fine. And another thing is, I just want to show you is that I do a lot of YouTubing and sort of things, which I will also share in my previous in the chat. Is that people have this that started. So if anybody is interested in machine learning, deep learning, and Azure ML and microservices, please go ahead and have a look at the channel. I keep on updating, so it's all community work.
That's great. So YouTube channel and all the links I have dropped in the comments. Everyone watching, please go ahead and check it out. Ambarish content. Once again, Ambarish, thank you so much for accepting the invitation. We really appreciate it. I know it's evening time here in India, so we like to go out and hang out with your friends and families. So thank you so much. We would love to have you back whenever we do. So we do these events like almost every day. We do live shows and conferences like almost every other day. So yeah, we'd love to host you back whenever you're available. Thank you so much. And yeah, have a nice Wednesday.
Thank you so much, Simon. And the questions were awesome from the audience and from you. Absolute pleasure in giving this session.
Thank you. Thank you so much, Tara.
Thank
Bye.
you. Bye-bye.
All right, with that, an absolute amazing session by Ambarish, we now take a break and move to the next session, that is a bot from idea to deployment. And here's a quick thing, right? So everyone watching today's session, I see some of our partners, Heiko. Heiko is an absolutely amazing person. Everyone who's watching, thank you so much, Heiko. Heiko's organization and team is one of our partners for this event. So really want to give a shout out to them. So everyone who's watching this live stream, right, please feel free to go ahead and ask a question in the comments. I'm really sorry for a quick some audio issues in the past session, but here's a little more update. This session and the following session is actually recorded, so I'm not sure if we will be able to take your questions, but yeah, the next session is by Sammy. Sammy is a Microsoft AI MVP, and he's going to talk about on how you can actually build bot from an idea to the deployment. So I'm really excited for that. And without any further ado, let's go ahead and watch this session by Sammy.
For joining me at the Cloud Summit today. Looking forward today to talk about a bot from ID to production. So today we'll be discussing 3 different topics. How are we getting to the ID of what kind of bot do we want to build? What infrastructure do we need and how can we convert it into code? And then of course, the most important part, the logic of your chatbot. And then at the end, how can we build the full CI/CD flow on that? My name is Sammy. I'm a CTO at Arinti, which is a Microsoft partner here in Belgium. And I'm a Microsoft AI MVP for already 2 years. And I'm also part of the global AI community as a board member. So let's kick off this session with the first topic of the day, and that is DID. So with my own firm, what we do is always start with a workshop at our customer. Why? Because our customers might have specific ideas about what they want to do with a chatbot, but for us, it's very important to make, first of all, a bunch of things clear to them. Many do not fully understand exactly what a chatbot actually does, how it works in the back, and we find it very important that they understand that because it gives them a better idea of what is possible and what is not possible. In the meanwhile, we explain them all the things that can go bad and exactly the pitfalls of projects that have happened over the last 5 years that we've been doing. We need to explain them that chatbots are mostly built to lessen the work done by your customer care center so that they can focus on the most important part of their job or focus on more important parts or more difficult problems that are there in the company. We will ask them questions like, what questions do you get the most and what actions do you need to take more often? And then also take in mind that they don't start building a process for something that happens only once in a while, because it will take a lot of time to build with a short return on invest. It's very important to set expectations. A chatbot is a piece of software and it needs to keep on living. It's a never-ending product because you always need to make it better. So it's very important to work on an ID that is in an agile way. A chatbot needs regular deliveries of small extra features. And then very important, and that's something that you need to make clear from the beginning of your chatbot, is make sure your customers know exactly what you need to expect. What does that mean? Well, in the first messages, already tell them, like, this is what I can do and this is what I can help you with. Now, after you've set up your ideas concerning what you want to do, now the next steps will be, how do you want to interact with your customers? Do you want to be extra polite to them and always talk to, hey sir, here, hi madam, or you just, hey you, how are you doing, being very casual? It's something you put in before you even start building your chatbots. We work together with the UX experts to be able to even draw out specific dialogues already. So it's been configured and drawn out what it will look like. And from there onwards, we can start developing the chatbots. So with other words, everything has been drawn out and written out what exactly the chatbot will do or say. And from there onwards, we can start developing and training our chatbot. So now we have our full ID, what we want to build. We know what the scope are. The scope is perfectly defined. Now we'll need to go into the next step. We know as an architect, solution architect, you know what services you will need on the Azure platform. Now let's start on building that. And that brings us to the second part of the session. Very important part, and it's infrastructure. Now we hear more and more about infrastructure as code. Now I'm a big fan of bicep code. Before we had ARM, which was okay to build infrastructure as code, but it was not always very readable. Of course, we also have Terraform, which is cloud independent. But since I'm mostly putting my focus on the Microsoft platform, well, I'm very happy with the code that the new environment that Microsoft created, which was called Bicep. So infrastructure as code, very handy, especially if you have an environment, for example, that gets, you have a lot of issues, then it's easily to spin up a new environment because everything is already in code. Same for all your apps and so on. In DevOps, we can fully have release cycles and manage it so that works perfectly. Now, for our bot infrastructure, we need to have a specific architecture, of course. This is a simple infrastructure design that I drew. The Bicep code, we will discuss that in a bit, is also available on my GitHub, github.com/Sammy Deprez/bicep templates, and there you will find bots also. So what's the code behind a chatbot? Well, it all starts with the logic of the chatbot, and that's all saved within this web app, which is of course running on app service plan. From there onwards, well, we'll need to do communication with, for example, Lewis to be able to understand what the human is saying, what the humans are saying. So data will be sent up and down to cognitive services language understanding. Now, from there onwards, we of course need to be able to save what has been saying. Since the chatbot is stateless, well, we still need to somehow keep track and being able to return, for example, what the variables were that were saved. So that will be all saved in our Cosmos database, which will be purely used for conversation state storage. Now, of course, within chatbots, we also have Q&A Maker to make a knowledge base which can easily be queried by questions and answers. Well, for that, we need another web app, which is the Q&A API, linked to the Cognitive Service Q&A Maker and the Azure Cognitive Search, where actually the Q&A knowledge bases are saved in. Now this is all on the back end. Now we also have our front end of the bot, which is this part, the right side here. And that first part is the bot channel registration. The bot channel registration is the front entrance to your bot. So it will make sure that there's communication from a web chat, from Facebook, from WeChat, and many Skype, Teams, or whatever channel that you're using. It all starts here. So there's a secure communication line between these two elements, between the web app and the bot channel. The bot channel registration can also be defined to be able to handle speech, and that's also being able to be configured in there. So therefore we also put the line here to cognitive services to the speech service. Here on the top we also see an Azure function, and that I always use for my authentication method for web chat. So that way we don't need to put a direct line secret into our web page where the chatbot is running in. It means we will do a call to the Azure function first to return the token, and then communication can happen between the web chat, which will communicate through the bot channel registration to the web app. And then of course to finish it up, we have our key vault to just keep track of all the secure passwords or keys that are needed. For example, our direct line secret or app ID or app secret that is needed also for the communication between these two. So let's have a quick look between on the bicep code how that looks like. All right. So if you go to my GitHub repository, you will notice this. That would be better. Cool. So you will notice this element here, and I need to move my face to another place so you can see it better. The code. It always starts from a main.bicep. If you go to the main page of the bicep template, you will also find the way how to deploy the code. So you have this can be done through the CLI on your own local computer before you even push it into DevOps. Now let's go back. So you see here that I call main.bicep. If we go to main.bicep, the nice thing about Bicep is that you can work with modules. So I've already written a bunch of smaller modules to automate certain things. So first of all, I set some parameters that I can also give in from my own environment if I don't give them in. So with the CLI, if I don't give the location, I can still override the location, environment, project name, admin user ID, and so on. Now with the admin user ID, it's the user ID that I'm defining. That's mostly the object ID of my personal account on Azure, so I have access to my key vault. Then I have my application ID and application secret. That's what I need to define, well, to actually create in my Azure Active Directory as an app registration. This app registration will be used for the communication between your bot channel registration and your bot logic. From there onwards, we have a bunch of services that we need. As you might notice, I prefer to use decent naming conventions, so I took over the Azure naming conventions, and each time we add the project name and the environment to the names. So we have a key vault, the app service plan, we have the app service where the bot is running on, the function to get the direct line token. We add some application insights for logging. We have a Cosmos DB. Then we have Lewis authoring and Lewis predicting. We have our bot service, which is the channel registration. We add the logic also in case we would like to use it, and later on the name of our Q&A and the name of our bot. This is the bot that will also, the bot name that actually is going to be used in the environments too. So what I added here is a little script, which this is still not correct yet. This bot name should still be a variable that I can also give into the CLI script. So then we have a bot endpoint. This is based on the app service name that we created our app on. I try to tag my services with a small description, what it's about and in what environment it is doing. And from there onwards, we're going to call multiple modules. And so the first one here is the module key vault. Then the next one is a module I wrote, key vault secret. Let me open it to actually add a secret into the key vault. So notice here, I make the key vault. So I have my module kv, and from there onwards, I can use kv outputs.name. And so I use the key vault name to add the secret, which is called bot app ID, with the secret value application ID. And this application ID is what I defined here. So let me go back to the modules, and there you see the resource that we're calling, the key vault name, the secret value. And what I'm returning is just the secret name, just to be able to add something. Now let's go back to our main. So from there onwards, I also add my bot app secrets. I create the server form, which is actually our app service plan. Then I create the websites, which is then again is the app where the bot is going to run, the logic of it. And notice here again, we have ASP, and I'm using here ASP outputs.id. So I'm giving the ID of this created server form to how to create the web app. From here onwards, I adding security. Well, I'm giving my web app permission to read my key vault. So here I use the app outputs.identity. So in this module, I'm creating also system identity for my web app, and I can go on. Then I create, do the same thing for my functions. I create my function here. I create a Cosmos DB. In the key vault, I add my Cosmos primary key. I create my application insights. Then I create my Lewis. Then my bot service, where I'm going to configure it with my application ID, the bot endpoint. So this is the messaging endpoint that we defined here on the top of the script. So we see here, this is our bot endpoint. Let's go back. We give some details about the application insights. And then once that is created, we get returned the bot direct line secret, which we're also saving into our key vault. Then after that, we configure our app settings with a bunch of stuff like our Microsoft App ID, app passwords. So this is needed to be able to communicate, to have a communication between the bot registration channel and the bot logic. So these details are needed in your app settings. I do the same things for our function, where I define the direct line secret, where I do not enter the value just like that, but I define it by telling it where in the key vault it is saved. That's also why, as well as the web app, as the Azure function needs permission to read the key vault. Again, that's a secure way, and you don't need to save any passwords in your code. And then we create our Q&A. Again, we say on which server farm it needs to run, so which web app. So we don't need multiple web apps. If you create Q&A maker manually in the Azure services, it will create a separate web app, which also means it will duplicate your cost for running your bot, because you need two app service plans then. By doing it manually, you can define beforehand already, this is the app service plan that I want to use. And that's it. And then we have a whole setup, and if we execute that, it nicely generates all the resources that you need. Now, this scripts that I will open here again. This AZ deployment group creates. This will create a resource group on your subscription, and at the end will create all the resources that are needed. It's also possible to create it on, you define already the, so in this case we defined already what the resource group is going to be, which can also create the scripts on a subscription level. And then you can run and create the resource groups manually in case you want to make, for example, a resource group specifically for networking. In this case, we didn't configure any VNet configuration, but it is possible. It would be nice if those resources maybe are in a different resource group, so you can keep networking and application separately. But that depends all on what your governance is on Azure and how you want to handle it. So let's go back now. We've seen all the parts now for Bicep, what is needed. Next step is now the code. So let's have a look on that. So that brings us to the last phase of the project, and that's of course, the biggest part of the project, that's building the code for your chatbot. So that brings us immediately to Bot Framework Composer, which I'm not gonna open up and show you around in it because that's not the purpose of this project, of this session, but we'll go straight into DevOps. So let's go here to my DevOps environment. All right. So what you see here is a project called Chatbot Robin. And on the left side, we click here on repos and then files. Now what you see here is the first part is here, which is called Robin. And Robin is actually the folder which is generated by Bot Framework Composer with all the details inside. I did not change anything to that, and I just add changes of my bot purely in there. Another part I have is my build template, and this is all defined by extra code that is actually from a part of the Microsoft Docs. So there's a specific article about setup continuous integration and continuous delivery for a Composer bot. It's still in preview, and it's something we are personally working on as a company also to still improve, because we still see some missing items, and we'll go over that in a second. So they explain it quite easily, all the steps that you need to take. It's all based on one YAML script that you need to take into your pipeline, and it will call different ones. So let's have a quick look on that. If we open our YAML script, to the first one, build and deploy. All right, so we set up a couple of keys, variables that we're defining, and from there onwards we will do install prerequisites, build and deploy models, and build and deploy .NET Web App. So let's have a quick look in each of them. So we'll start at the prereqs. So in the prereqs, we're just installing nodes using the Bot Framework CLI, so we can actually trigger, for example, a training script of Lewis or a Q&A maker, and then we just configure what .NET Core version we want to use. Let's go to deploy the models. So again, we set some parameters. We configure our working folders, but then here, most importantly, training or language understanding models. Here you already see we use the PF CLI, so the Bot Framework CLI, to use the generated language understanding files that were generated by Bot Framework Composer, and to ship it to Lewis to train it, all the different ones. And then in our next step, we're actually going to publish Lewis via a PowerShell script. Second part, after Lewis, we want to publish our Q&A, send all the knowledge base information, and then the third part is generating an orchestrator model, which is very important to have a good combination between your Lewis and your Q&A models. After that, we're just generating an archive, and we publish that archive to our generated.zip file. So with this, our Lewis model is trained, our Q&A model is trained. Now the last part is training, well, not training, is publishing the bot on itself. So if you go back, we have build and deploy.NET Web Apps. And if you go down, we do a build the bot, we publish the build artifacts, and here we deploy the Azure Web App, and we configure it with some parameters. In this case, the Microsoft App ID, app passwords, Lewis endpoint, Lewis authoring endpoint, the region, the environment, the default language, and so on, Lewis name, and the different app IDs that needed for this. So there's a bunch of parameters that needs to be configured. Now, once this is all done, normally you don't need to touch these YAML scripts, and is it only the first one, the build and deploy script. Now, once that you have that, if you go to pipelines, you can say I want to create a new pipeline from an existing YAML script, and then you can just, then you'll have something like this. So it will create a pipeline, and each time, depending on, let's open here our YAML script again. We see our trigger now as production, but you could have different ones between your environments. So in this case, we have a dev environment, which has a separate build and deploy YAML branch from. Okay, so it can be different depending on the different repositories that you have. And that's one thing I wanted to share concerning what we have here. So we have the Microsoft provided these scripts to be able to automatically do deployment of your bot, which is perfectly working if you have one environment. Now with a CI/CD environment, you might have a dev and acceptance and a production environment, depending on your use case. Personally, I think it's always good to have at least a separator between dev and production, so you can also play around with new things and you don't crash your production, so it's more stable. Now, because of working with pipelines here, we do not really have releases. So this is something I'm still working on. It's something that I will be sharing with the community soon, once it's up and running. So then the idea would be that you have a pipeline that does all the checks and will do the builds and see if everything is in order. And then you will have a release pipeline where you can say now it automatically goes to dev, and when you say okay, it's ready to go to production, you can just push it to there. So I hope this gives you a bit of an overview of what is actually possible with Bot Framework Composer, bringing it first, getting your idea of what you want to build, getting your infrastructure as code, which was already shared in my slides, that you can perfectly reuse. And then, of course, once your bot is there, to set up the full pipeline from dev to production. As I said, it's still a work in progress also on my side to finish that up and make it available for the community. So keep on following me on Twitter. It's @Sammy Deprez, or just like my GitHub page, and you for sure get an update once it's there. So thanks for joining this session. I hope you enjoyed it, and enjoy the rest of your day with more awesome sessions coming up.
All right, that was an absolutely amazing session by Sammy, where you learn how you can go ahead and get started with bot, not only get started, but also take it to the production with pipelines and all. So unfortunately, we won't be able to take the questions. As I said in the very beginning of the session, that it was a recorded session, but I see many people joining in. Hi, Andrew, thanks for joining in. Andy says it was a nice session. Then people are joining from Nigeria. Ganesh, thanks for joining once again. And let's see if we have many more people joining. So thanks everyone who is joining. A quick And general reminder that we have the contest going on. Please feel free to go ahead and participate in the contest. There are 3 contests. The first contest is whenever you go ahead and drop a comment in the chats, more specifically when you ask a question to the speaker or share your thoughts for a session, please use the hashtag Cloud Summit without any space between Cloud and Summit. And towards the end of first half of day 3, we're going to pick winners from the comments. And also we have the contest going on for Twitter and LinkedIn. So take a screen grab or a selfie or be creative in any way. Put it on social media, tag us at C# Live, both on Twitter and on LinkedIn using the hashtag Cloud Summit, and we'll pick the winner towards the end of the day. So until now, we have had 2 sessions. The first session was by Ambarish that talked about how you can use Azure Custom Vision Services. Absolutely amazing. You need to write any single line of code. Everything is done. So if you are a developer but not an AI developer, or if you are not into data science, you can go ahead and get started using Azure Custom Vision. And the second session was in depth by Sammy, who was a Microsoft AI MVP, where he did show you on how you can use, how you can go ahead and build bots from idea till to the deployment. So hello everyone, thanks for joining in. Please don't put the hashtag itself. Share us your location from where you're joining. Right, it's always very interesting. Just the hashtag do not count as the valid entry. Having said that, our next session is by Javier. Javier is going to talk about introduction to Azure SQL. And if you're someone who's, if you have been following the organizers of the event, that is C# Corner, in the first quarter, that is the first quarter of this year, in the January, we had a SQL Server virtual conference that was 2 days dedicated just on SQL. And there we had many amazing sessions. So we have one speaker from that event. That is Javier. Javier is going to talk about introduction to Azure SQL. All right, so we have see people joining us from Noida. That's absolutely amazing. Then we have people joining us from Madrid. That is great. Hi everyone. J-Star is joining us from Beachside. That's great. So welcome back, everyone. This is day 3 of Cloud Summit 2021. The following session will also be recorded, so I'm really sorry we won't be able to take questions towards the end of the session. But please feel free to share your thoughts about Azure SQL databases in the comments. And I see, all right, people are joining us from South Africa. People are joining us from Bangalore. Then we have people from Hyderabad, Pune. So the next session is on introduction to Azure SQL by Javier. So enjoy the next 30 minutes on how you can get started with Azure SQL if you're someone who's very new.
Good morning, good evening, good afternoon, and welcome to Cloud Summit 2021. It's a pleasure for me to be here today presenting in this great conference. Thank you so much to the organizing team and the sponsors to make this kind of event possible for all the community. Today, we will have a quick introduction to Azure SQL. We will see all the different flavors that we can have in Azure of the database engine that we all use and love. A little bit about myself. My name is Javier Villegas. I am from Buenos Aires, Argentina. I work as an IT director in DBA and BI services at MSC. I've been working with SQL Server for over 20 years. I am Microsoft MVP in the data platform category since 2016. I am Microsoft certified trainer, and I'm also member of the board of advisor of the Azure Data Tech community. I also define myself as a technical speaker in where I go to all the events that I'm invited to talk about SQL and Azure SQL. On the left side of the screen, you have all my contact information, email address, LinkedIn, Twitter, and my blog. feel free to reach me if you have any questions in regard to this presentation, or if you just only want to connect. So let's start. This is how I would like to picture Azure SQL, right? This is this new umbrella that Microsoft put just to group all the SQL offering in Azure. We will see three main components plus one which was added recently. The first one is Azure Virtual Machines. This is basically what Microsoft called infrastructure as a service. It's a virtual machine pre-configured in where we can run SQL Server. The same SQL Server version that we've been using forever, right? This is quite interesting because from the Azure portal, you can go there and select from the gallery any combination between operating system, SQL Server version, and edition. You know that since SQL Server 2017, we can run SQL Server in Linux, right? So we can also choose whether we use Windows or Linux, whether we use SQL Server 2014, 17, 16, 19, Standard Edition, Enterprise Edition, the one we need. What it is really interesting is that if we choose one of these predefined images from the galleries, we have certain best practices regarding to SQL Server already pre-configured. Like, for example, how you distribute the data file, the log files, the location of the 10DB, several things. It's important to mention that this offering infrastructure as a service is something that is quite similar to what we've been doing today on premise, right? We have to handle the infrastructure behind SQL Server. So we also have to administer the operating system and the VM. With that, if you need to apply a patch to your Windows Server, to your Linux, this is something that you have to take care of. If you have to apply a patch to SQL Server, right, it's also something that you have to take care of. If you need to set up, for example, authentication, Windows authentication, or Azure logins, right? You also have to set up your own virtual machine, run Active Directory, etc., etc., etc. If you need to set up high availability and disaster recovery, you have to create the window cluster with an additional virtual machine, configure the clustering, configure the availability group, do the whole thing, etc. So this is something that we've been doing today. Also, if we need to take care of doing the backups, right? This is something that we need to take care ourselves. Nowadays, Microsoft is also trying to help us with all these tasks that we need to do in order to maintain the environment, like the backups and high availability, maybe doing some of this point easier from the Azure portal, right? But again, this is something that we have to control. We have to take ownership, right? And the beauty of this option is that since it is the same SQL Server version that we have and we've been working on, right? A migration from our on-premise environment to an Azure virtual machine is extremely easy, right? Because it is the same SQL Server version. Then we have the other option, which is actually two options which are under the category of platform as a service. What is platform as a service? Well, Microsoft provides us with a SQL Server endpoint in where we just connect to that endpoint, and we don't have to worry about the infrastructure behind the scene. We don't need to worry about the host, if it is Windows, if it is if there is a missing patch, nothing, right? This is platform as a service. So we connect to the SQL Server. And all those things that I mentioned before, like, for example, backups, patching, high availability, disaster recovery, those tasks are covered by the service itself, right? We don't have to worry about doing those kind of things because it's part of the service. It's really, really a good option, right? And let's describe the two offerings within the platform as a service offering. First one is managed instance. Managed instance is something that we can define as almost 100% compatible with SQL Server, right? But again, as a service, right? When I said almost 100% compatible, we can say that all the features that we've been using from SQL Server, like, for example, replication, CDC, service broker, all the T-SQL that we know, of course, triggers, store procedures, SQL Server mail, everything that we know is there. There are only a couple of things that are not fully implemented, but beside that is, again, a great solution for hosting our SQL Server application, our SQL Server databases, right? Without any big re-engineering or of the application itself, right? So this is managed instance, focused to be a replacement of our SQL Server virtual machine or our SQL servers on-prem, right? With the benefit that we said before regarding to platform as a service. This is a relatively new service in Azure. Then we have another service which is actually not that new, is Azure SQL Database. And in fact, it was one of the first services that were available in Azure when it was presented many years ago, right? Again, under the concept of platform as a service, without us taking care of patching, high availability, etc., right? We have this offering, which is a little bit different than managed instance. And what is the main difference, and why we have two different flavors here? Well, Azure SQL Database, one of the main characteristics is that everything had to live within the same user database. What do I mean with that? If you have an application which requires the database, and the database has a procedure which is joining tables from different user databases, you cannot use Azure SQL Database as it is, right? Because again, everything, all the objects from my application have to live within the same user database. So if this procedure, which is joining tables from my user database, but it's also joining tables that are in a different user database, well, we cannot do it as it is, right? For that, we have the possibility of having managed instance, which is much more similar than SQL Server, right? So is this a limitation? Definitely not. I mean, just having everything on a user database is not a limitation, it's an important characteristic and something that we have to consider here is that Azure SQL Database is more targeted to modern application, right? So let's say if we want to come up with some sort of rule to see which one we use, how, when, etc., I would say that the easiest way to do the first step migration is, let's say we have this application running on premise for many years and we want to go to Azure, right? The easiest way to do it is, okay, we come up with a virtual machine with the same SQL Server version that we are using, or maybe the latest one, and we also migrate the SQL Server version. This is going to be the simplest one, right? But right after having the application up and running in this virtual machine, we should start uh, testing and checking the possibility of using this existing application using managed instance, right? The migration from SQL Server to managed instance is as easy as taking a backup and restore it to the managed instance. It's really, really easy. But if, let's say, we have a request to start working on a new project, right? A new development that will require a database engine as a backend, definitely we need to take a look to Azure SQL database, right? Again, if we start writing from scratch, most probably Azure SQL Database is the right choice. If we need to migrate something that exists, well, most probably, I mean, virtual machine is the first choice, and then the final home for our application will be managed instance. So here we have some points of each of the offerings, right? Something to review maybe later. But what I would like to focus on is on this difference between infrastructure as a service and platform as a service, and which are the benefit of all this offering in Azure. First of all, we have this concept of business continuity, right? We do have multiple options that allow us to have a highly available environment in Azure, right? In any of the options that we mentioned before. In terms of backups and backups retention, and also backup, let's say, storage, or where do we store those backups that we do, right? Azure gives us the possibility of handling the backups automatically, having a retention of several years, actually, and with the addition of having a copy of those backups in multiple Azure regions. Right? Those are things that are really, really important, because if we're trying to certify any of the ISO certification, well, this is one of the important points that is required, right? How we do the backup, how we retain the backup, and how do we store those backups. Then something really, really important from Azure, and something that, you know, with Azure SQL we can take a lot of advantage, is the scalability, right? We can really easily scale up or scale down any of the three offerings that I mentioned before: virtual machine, managed instance, or Azure SQL Database. If we have today this environment running on premise and we need to, let's say, add more memory, or improve the disk performance, or maybe add more processor, well, it's a little bit, it's a complex process in where you know, you have to buy the hardware and physically put it within the server. That could take some time, right? Weeks or months. Well, within Azure, if you need to assign more resources, CPU, memory, disk, to any of the Azure SQL offerings, right, it's a matter of few clicks, right? So easily you can scale up or you can scale down. You have all the security that is part of SQL Server, plus the benefit of the security that we have within Azure. Something really important to mention here is that Microsoft is focusing on Azure SQL with the slogan of "it is just SQL." So all the knowledge that we have on how to write Transact SQL, right? We can use it. We can keep using it with absolutely no problem. So definitely something that I would like to emphasize. Another important thing is this concept of versionless. For managed instance or Azure SQL database, right? There is no version. There is no 2016, 19, 2016. There is no edition enterprise standard, right? It's Azure SQL, period, right? With that, we have this continuity of the Azure SQL environment, so we can also rely on it and work in the future. Something that today, if we need to do a migration from one version to the other, it's a complex process that we need to work with and really do a lot of testing and make sure that everything works completely fine. Well, with that, with no version, right? This process is a little bit more easier. I'm not saying that we don't need to, do anything, but definitely it's easier than what it used to be. Being versionless means that this is static. There is no improvement. There is no new features. Absolutely no. Microsoft put a lot of emphasis on new features in Azure SQL first, right? So we can see new features in Azure SQL database or in managed instance way faster than what we can see it in the on-premise SQL Server version, right? And then we have the monitoring and the intelligent framework that we can have within Azure. So what we can say is that now with this offering, we don't need to deal with hardware contracts. We don't need to worry much about the backups because it's all these things are built in as part of the platform as a service offering high availability, disaster recovery, monitoring, and upgrade. These things are part of the service. If we have an existing application, an existing set of databases that we need to migrate to Azure, Microsoft give us Database Migration Assistant and Azure Database Migration Service, which are, a tool and a service that help us to do different type of migration, online migration or offline migration. So virtual machine, if we focus on these virtual machines, well, these are the points that we really need to consider. Do the right selection through the marketplace, and then if we need to monitor and take care of these virtual machines, this is something that we've been doing forever, taking care of the storage, the CPU, the memory. Those are the things that we need to monitor and take care of, right? So within Azure, within the portal and this framework, definitely is easier. It's really easier and something to really consider. And then, managed instance, as we said, this service that allow us to move our databases simpler, sorry, as well as Azure SQL database. So here we have one or the other, and we should set the rule before, right? For migration, managed instance, for new projects or new deployment, Azure SQL databases. So now, we took the decision, we go to Azure SQL, we go to a platform as a service offering. If we consider managed instance, we have two options, right? Which are called tiers: general purpose and business critical. General purpose is, according to Microsoft, is a good fit for most of the business workloads. And if we need additional, lower latency and additional read-only replicas, well, we can also choose business critical. This is based on the B core model, so we have to choose the amount of virtual cores that we have in each of the offering. Azure SQL database, initially there was a model called DTU, based on DTU, database transaction unit. This is still there, but now Microsoft is also recommending the B core model. And again, we have the general purpose tiers, business critical tier, and there is an additional tier called hyperscale, which is a great fit for big database deployment, right? If we are talking about hundreds of terabytes, definitely hyperscale is the tier that we need to consider. How do we connect to Azure SQL? Well, first of all, to do the creation of the services using the Azure portal. Then, when it is already created, how do we work with? Well, with the tools that we've been using since forever. Management Studio, the new Azure Data Studio, and then, we can use different connectivity options like PowerShell, the CLI for Azure, SQL CMD, and T-SQL, of course, right? So, as a summary, right? Azure SQL is the evolution of the best SQL Server engine in the world, SQL Server. Azure SQL includes virtual machine, managed instance, and databases. And if you remember at the beginning, I also mentioned a fourth component, which is Azure SQL Edge, which is SQL Server or Azure SQL running in ARM devices, like for example, a Raspberry Pi, right? This is a good fit for certain scenarios related to Edge. SQL Server on virtual machine is the best fit for 100% lift and shift. So I have this in premise, I have the same in this virtual machine. Azure SQL Managed Instance is the great power of the database engine with the benefit of platform as a service. And Azure SQL Database based for modern cloud application, right? Let's see quickly this in action. So I have here my Management Studio, and I am connected to my three offerings here: my virtual machine, an Azure SQL database, and a managed instance. So I have, the same user experience that we can have with SQL Server, but with the other offerings. If we go to the portal, right? We go to the main portal, we go to Azure SQL, and these are my existing resources. So if I want to create any new Azure SQL component, I have databases, right? Managed instance or virtual machine. See that, for virtual machines, we have, as I said at the beginning, different combination of platform, Windows or Linux, and different SQL Server versions and edition. For example, we have Windows Server running on SQL Server running on Windows Server 2019. Then here we can also see 2017 running on other SQL Server in other Windows versions, right? We have here 2019 running in Red Hat, Ubuntu, or SUSE, right? So definitely we have a bunch of options here. And as I said, if we need to connect, we have Management Studio, we have Azure Data Studio to work and connect to any of these offerings. Again, absolutely no problem. All right, so this was a brief introduction to Azure SQL, right? Another good benefit is that with Azure SQL, you can integrate it with many other Azure services like Data Factory, Cognitive Services, Azure Databricks. All the Azure services are really well connected with Azure SQL. So if your project not only required relational database, but also required any other component related to NoSQL, big data, machine learning, you can easily integrate it in this scenario. Okay, very good. I have a final slide here, just to, if you want to learn more about Azure SQL, I leave you this QR code to go directly to the Microsoft documentation. Everything is well detailed, and the documentation is really great. And with that, we finish this presentation. Again, I have my contact here, so LinkedIn, Twitter, email. Don't doubt to contact me if you have any question regarding to the presentation. And with that, thank you so much. Have a great conference, and we stay in touch. Bye.
All right, that was an absolutely amazing session by Javier on how you can go ahead and get started with Azure SQL. What is it? What are the benefits, and why you should learn Azure SQL and ask your managers to start using Azure SQL. Having said that, I do see some of the comments from the viewers that they've asked some questions. But as I said, this session was recorded, so Javier, the speaker, won't be able to answer it. But I think our next speaker who is joining, the Wolfgang, I see him as a data guru. He may be able to answer some of the questions in the comments, and I bet he can do it. But we'll first let him complete his session. Coming up next is Wolfgang, who's going to talk on data, why you should govern your data. It's a session focused on Azure Purview, and I won't take any more time and invite our next speaker, Wolfgang. Hi, Wolfgang. Welcome to Cloud Summit 2021.
Hi, Simon. Thank you. How are you?
I'm doing great. I'm really excited to have you back once again. I think we did connect in the SQL Server Virtual Conference, right? Or maybe Power Platform.
I'm not
I
sure
don't know.
if both. I can't remember.
Me too. But somewhere we both connected this year, early the first quarter. So how are things at your place?
It's okay, depending on the
It's okay.
pandemic, but it's okay. Yeah,
Yeah,
let's see
things are
what.
getting better, right?
Yeah,
People are going back to offices, so yeah, I think things are getting better. We'll have to figure out on how we take these events to hybrid. That's next.
yeah. I'm going to Denmark for the
Wow.
first in-person conference tomorrow. So
In
yeah,
past 2 years almost.
yeah, 1.5 year, first
Yeah.
one. Mm.
That's great. That's great. So, Wolfgang, today you're going to talk about Azure Purview, but I was just reading the abstract. It looks very exciting. So I won't take much of your time. Please feel free to go ahead and share your screen, and then you can get started.
Yeah, perfect. Thank you. So
And everyone who's watching, please feel free to ask any questions to Wolfgang in the comments, and we'll take all that towards the end of the session. And yeah. I can see your screen. You're inside
screen.
StreamYard. Once you move away, I'll add it to the stream. Yes, I see your presentation. Yeah, and next 25 minutes is all yours.
Okay, thank you very much, and welcome to Cloud Summit 2021. I'm happy that I'm with you and I'm able to talk about data governance, the data what, and first and foremost, why you should govern your data and why should you think about a solution for cataloging your data, for better knowing your data estate in your company. And I'm Wolfgang. I'm coming from Austria. I'm working and living in Austria. I'm working as a data consultant. And what I see is there's data everywhere. When I just look outside, well, there's data on the red house, there's data on the other house, there's data everywhere I look. And especially when I come around and have a look and I talk with our customers, there is almost too much of data. There is data collected everywhere. There's data collected and transferred from system A to system B, and almost nobody really knows what is happening in my company, what is happening in my network, what is happening with my databases, with my data warehouses, where is that data stored? And what we often find and see, my company, my colleagues, we are building analytic systems, data warehouses, data science applications. And what we really see is those data islands. All those data, data pieces, they are there in your company, but they are not connected. So there is maybe one ERP island, there is maybe one CRM island, and there is, I don't know, a web shop island. But all the data that is stored in island 1, 2, or 3, it's very important to have it in your company to be able to analyze that data. But you don't really know, and sometimes those companies, they don't really know what happens in between. Is there a data exchange? Sometimes they know, yes, there is a data exchange, but know what are the connecting pieces, what are the connecting processes, and so on. So what would be really important for you to know, if and are there any bridges between your data islands? Are there bridges that look like that one on the picture? So really good built streets and so on? Or are there some, let's take data from there, store it in an Excel file and put it somewhere over there, bridges? So we don't really know if we haven't had a look at all our data. And sometimes it's more like, we know there must be some data of kind customer, for example. We are storing customer, we are processing customer data somewhere in our databases. But we have to look where it is stored, and what would help and what really helps in that case, it would be a data map. Something that would enhance our data estate and something that would catalog and build some sort of map, with continents of ERP, with a continent CRM, and we've got bridges between those islands. As you can see here, there are connections between those two. And what is really, really necessary in order to build some kind of data map, we need to collect all the information. And what is really important, don't collect the data as you see it in the picture. So there's many books over there. But if you're looking for a Russian book, maybe we should start here and grab all the books and look for a Russian book. So it's not that easy to find the right information, especially if you're looking for one specific kind of data. That orange piece, you are looking for the customer data. You are looking for the field in your database that contains customer numbers. Or let's talk about legal information like GDPR requirements. You have to delete all your customer data that one customer requested for you to delete it. And you have to look in your data estate, and you have to look for every piece of data, of customer data, that is available somewhere. And if you have no catalog, it's not that easy. And the catalog, well, it needs to be ordered. It needs to have an index. It needs to have some sort of ordering structure, and maybe you need some sort of database, some sort of catalog. Maybe you need some sort of search to be able to find the right book. And I know that picture, so it's easy for me. If I'm looking for a Russian for Dummies book, well, that one is here. So it's really easy if you know how all the pieces, how all the knowledge pieces in your environment, in your enterprise are sorted, are collected, are, well, indexed. So what is needed for us to get away from the library into our data estate? Well, we need something that is called data governance. We need something that is called a data catalog. And what I would like to talk today about is Azure Purview. It's a new service from Microsoft. It's a new service, well, that focuses on data governance. It was introduced in December last year, so 10 months old, and that screenshot is taken from the website. So reimagine data governance. And if you talk about data governance, and if you interview 2 or 3 people, you get, I don't know, 10 pieces of information what they think that data governance is. So it's not that easy to find the right definition and a right definition of data governance. Data governance it includes like cataloging your data, to know where your data is stored, to know who is responsible for your data, to know where the data is stored and transferred to know the processes, what are defined around your data, to know the different permissions, who is able to access the data, and so on and so forth. For Azure Purview, although it's called a data governance service, the initial version, the version we are talking about today, it's a data cataloging solution. So it's a tool where you are able to map your data. And it doesn't matter if the data is on premises or in the cloud. It doesn't really matter if the data is stored in the Azure cloud or in Amazon cloud, for example. And what it does and what it helps is it discovers trusted sources. So what you have to do, and we will see it in the demo, we have to define, okay, that's a SQL server in our environment. And the next step, well, Purview scans that source. It does the technical inventory, plus it does some sort of classification. And the classification can include classifications like that's an email address, that's PII data, so privacy data, that is a custom classification like a customer number. We will see it in the demo. You can build custom classification rules. And you can also, with the help of Azure Purview, understand your data supply chain. So data supply chain, well, it's data is stored here and data is going there, and maybe is data going there. So we have some sort of data lineage. We have processes that take data, store data somewhere, transform data. And that is really important to really understand your data landscape. And last but not least, that's the first three things, those are the technical pieces. But what we really need is we need to include the business. The business context is very important because a table called cust or customer, well, that could be a customer table. But if we add some business context, business glossary terms like that's a customer, that's a supplier, that's whatever, the business is able to work with the data catalog. And as I said, Azure Purview in the current version, it's mainly focusing around the data catalog. So what's inside Azure Purview? Not correct. We start with the outside. We start with the sources. So the sources can be cloud-based. They can be multi-cloud-based and or local. So we can scan a data lake. We can scan databases. We can scan SAP. We can scan data lakes in Amazon and so on. And what is needed? Well, there are scanners. Purview comes with built-in scanners. And those scanners are the connectivity process to the sources. So a scanner in Purview does two things. First, source, it understands the source and it extracts the information, the technical metadata. Like in a database, you've got schema, you've got a table, you've got columns, and so on. You've got views in there. So technical inventory. The scanner does the technical structure. In a data lake, you've got some folder structure, you've got files in there. And that is the first step of a scanner. The next step is the classification. And classification can be done and is done first in an automatic way. So Purview, after it knows the technical structure, like the database structure, the tables, it takes a look at the data in there and tries to apply some classification. Those classification rules, there are 200 something built-in classification rules. Plus, you are able to create your own classification, your custom classification rules, like based on a regular expression, based on a dictionary lookup, in order to get some sort of, I often call it a stamp, that table contains email addresses, that table contains customer data, that table contains, for example, Austrian passport information. There is a system classification rule for that. And with that information, the technical inventory plus the classification rules applied, well, the data map can be built. Because the data map, well, Purview scans not only one source. If you register multiple sources, those pieces can be connected, as you can see here. Purview allows you to build some sort of network, and that is the data map, the ERP continent. And within that continent, we've got cities of data, we've got streets, we've got roads, we've got bridges between those continents. And the result, well, it's the data map. In addition, well, there can be some sort of hierarchy, like in a database, we've got schemas. Within a schema, we've got tables. Within a schema, we've got views. Within a data lake storage account, we've got folders, we've got subfolders, we've got files in there, and so on. So that is really the thing that the data map is focused on. The data catalog, well, it uses the data map. And you can use the data catalog front end to search the data catalog, to have a closer look at the information at your data map and maybe your data lineage and your data supply. And I haven't mentioned the thing that those scanners can also include Azure Data Factory, integration services. So those data transfer and data preparation, data integration tools in order to get some information that data is flowing from here into there, and we've got some information in there. So the data catalog, search your data estate, get to know your data supply chain, plus the ability to add business context. So those business users are able to apply, to work with your data, to edit the information. For example, a data steward, a data expert in a certain area, and to search for all those information. And the data insights, they are built into the Azure Purview Studio. Well, they allow you to have a closer look, how many scans, how many files, how many assets are there in your Purview account. And if there is no built-in scanner for system A, well, there is an option for using an open API, because Azure Purview is built on Apache. And that Apache Atlas, well, it's the open source data governance software. And the open API based on Apache Atlas, well, it allows us to read data out of the data catalog, the data map, plus to write data into that data catalog. So if there's a system that has no pre-registered scanner in Purview, well, there are inventory systems, there are API calls to put the metadata into your Purview account. And with that, let's start and dive into Purview and see Purview in action. So where is my browser? When I open the Azure portal and I open the section for the Purview accounts, well, in my environment, there's one Purview account, and one might ask, why should I create another Purview account? Just think about, maybe I would like to have some sort of testing, some sort of dev infrastructure. Maybe I would like to have a separated prod infrastructure. And before August 2021, there was a need for separating dev and prod, because whenever you created a Purview account, you either had access or no access. There was no way to separate the different pieces of data. No different continents could be permissions added. So it was either, yes, you can work with Purview or not. So there was a requirement. If you already created a Purview account, and I'm going to switch to that one, there is the Purview Studio. That is the one-stop shop for everything you need to work with Purview. And if you open the Purview Studio, well, you can just select the Purview account and switch to that one. In my Purview account, in my demo account, I've already, as you can see here, I'm going to zoom in a little bit, registered 11 sources and roughly 570 assets are in there. What is an asset? Well, an asset is a piece of data. An asset is a database table. An asset is a file in a data lake. An asset is an Azure Data Factory pipeline. So those are assets. And what we need to start with, well, it's the Register Sources button. So I'm going to go here. And in my demo environment, well, I've already registered 11 sources, as you can see, with having different types like Power BI, Azure Resource Groups, Synapse Analytics, SQL databases, and even an on-premises SQL server. So in order to be able to scan an on-premise SQL server, you need a self-hosted integration runtime. Whenever you've worked with Azure Data Factory, Synapse pipelines, well, the integration runtime, it's the connecting piece to your on-premises data sources. And it's the same technology for Purview to connect to your local SQL, for example. There's a data lake registered and so on. If you want to register a new one, register here and have a look at the list of available scanners. So those scanners are built in Azure, mainly focused on Azure. As I said, it's the data lake storage accounts, Synapse dedicated pools, MySQL, and so on. But it's not limited to Azure. It's Oracle, SQL Server, Teradata, BigQuery, and Power BI, well, Microsoft again. But there are other services and apps like SAP, Looker, or Irvine to integrate the data, the metadata out of those systems. And creating and registering a source, it's only half of the win, because that is, well, it's more or less a connection string. It's more or less, well, the name of a SQL Server endpoint. If I switch to a SQL Server database in the cloud, edit that source, it's, well, the database name. Nothing special, nothing more. If you want to know and want Purview to know more about what is actually in there, you need to register and configure a scan. And the scan, well, is applied to a source, and a scan does the technical magic. So grabs the structure, does the inventory, plus applies the classification. And if we have a look at one of those databases and one of those already configured scans, well, I've already ran them, assets discovered, classified, and so on. And if I go to the edit scan, well, we need to define what is the database we want to scan. And in the next step, for the database, we can define the scope. Do we want to scan the whole database? In a data lake, for example, you can select or deselect containers, you can select folders, and so on. And for the classification, it's the piece where the scan rule set applies. And the scan rule set, well, it contains the information. What are the classification rules that should be applied on your data? And you can use the system-defined ones, the system default ones, or you can apply custom scan rules. I'm gonna go back and go to the management. So classifications can be available in the system list. There are 200 something, like the Austrian identity card, passport number, and so on. And there can be custom classifications. And in my example, I've added a custom classification, which is called Wolfis Kunden, and Kunden equals customer. So I'm going to look for customer numbers in my data estate. And how does Purview does the search and the classification? Well, you can apply custom classification rules. In my case, I've created a custom one, Wolfis Kunden classification rule, which actually is a regex, regular expression. Like in every field, Purview encounters a regex following the pattern KU for customer or Kunde in German, followed by 4 digits. Well, that should be, and that is, well, a customer. It's my customer, or those are my customers. So that is the classification. And the scan rule sets, that is the combination of what should be scanned and what classification rules should be applied. In order to better understand, let's have a look at a custom classification rule for a data lake storage account. So I'm going to have a look at that one. And what should be scanned? Well, those are the file types. What should be applied? Those are the classification rules. I've only selected 13 of the system ones and my 3 custom ones. So that is the information that you need to configure for your scan. And whenever a scan is done, the list of assets is filled. And the assets, as I said, if I start and head over to an Azure SQL database, well, I'm going to move to that one, the AdventureWorks. I've got a DBO schema, I've got a sales LT, and I open an Azure SQL table. And that is the detailed information of your asset in your data catalog. Properties scanned out of the database plus the schema, all the information that was there. And what is also available, well, it's the context section. What you can do is you can edit that information, and we can add a technical expert. For example, I'm going to add myself in here, and I'm the technical expert. So we define who is the technical expert for that kind of data. But searching or working with a data catalog and actually to know where the data is stored, not the best solution. There is a search, and we can search for customers, for example. And what we get back is the list of assets that contains the search text customers somewhere, maybe in a table name, maybe somewhere in a Power BI data flow name, maybe in a file name because it's stored in the data lake. And that is the list of 22 pieces, 22 assets found. What you can actually do on the left side, you can filter based on the source system. You can filter based on the classification. And as you can see, email address is system 1, EU phone number, US phone number is system 1, EU mobile number, and the DBCC Wolfiskunde, sorry, those are custom classifications. And if I want to further narrow down those results, I can just select all the pieces that actually have customers classification applied. Head over to the customer table in the database, and as you can see, there is a classification added. And there is also schema classification, because schema entries, like columns in the table, can also contain classification information, like email addresses, person name, phone numbers, and so on. And that is one of those main things. What is still missing? Well, it's the business approach. It's the business glossary terms that are here. You can define the glossary. You are responsible to apply those glossary terms to your assets. So I'm just gonna go back to the customer, selecting that one, editing, management, and I'm gonna selecting, or that one already has 3 glossary terms applied. Can add another one, the German, which is the business partner, save that one. And that is the way to add metadata, business relevant metadata, which can also be used as filter. Last but not least, we are nearing the end of the presentation. It's the data lineage. I started with the supplier table in an Azure SQL database. Schema information is there, and there is also lineage information in there. And what you can see here, data is flowing out of a file that is stored in an Azure Data Lake storage, transferred and moved by an Azure Data Factory pipeline into a SQL Azure database table, taken by another Azure Data Factory pipeline, and stored into another SQL database. And we can switch the assets. Everything is hyper linked, connected, and so on and so forth. You can even track the information of specific columns all over the data lineage. And the pipeline information, the data supply chain information, well, it's pushed from the source systems, like the Synapse pipelines. If you have run a Synapse pipeline, that lineage status is automatically pushed into Azure Purview. You only have to configure the Azure Purview connection. And with that, we've seen Purview in action. We've seen a crash course into Purview. What are the main pillars? Sources, scans, classifications, data assets, data lineage, and your data catalog search. And with that, I'm at the end of my session, and I hope that you got some kind of feeling how easy it is that you can start to govern your data as of today. And with that, thank you for attending my session.
All right, Wolfgang, that was, if you just go back and look at what I really loved about your session was that pace that you had, right? There's a very good rhythm on every slide and everything that you said. I really loved it. We have a couple of questions, a few questions, and we still have time. So let's start with the, okay, I have to figure it out. It went into the top. Okay, let's start with this one. Okay, Cloud Summit, is clustering method are used in this Azure cloud? I don't know if that makes sense.
I have to answer, I don't know.
Yeah, me too.
Yeah.
I just popped the very first question I saw it. Let's look at this one. To keep on top of data governance issue, any suggestions, best 3 places to check or keep an eye
on? If I understood it correctly, what are the resources to start with data governance, or?
Yeah, some of any resources people would like to always go back and check. All right.
What is a really good thing is the tech community blog from Microsoft. There is a special section for Purview. For data governance itself, there are data governance groups on LinkedIn, for example. And I can share those links on Twitter afterwards. So if you follow me on Twitter, I can share those links afterwards. So LinkedIn is a good resource, and there are good webinars around that topic. And I forgot to mention one really, really important one. Just head over to the Purview Studio. There's a huge webinar coming on September 28th. Purview team, it's called Azure Purview Digital Event. So register, tune in, and let's see. Purview is in preview as of today, but there is an event at the end of September. Let's see.
Yeah, I mean, there are a lot of events happening in the month of September. I also see this one a serverless conference happening by Microsoft even towards I think it's September 29, somewhere falls around the same time. Let's see, this one question, it says, what type of data should be stored in metadata?
What type of data? The more you can grab, the more data you have to define your metadata, the more data you find to describe your data, store it there. Especially with the Open API, there's a way of creating properties, there's a way of adding descriptions, everything you need, because in the data catalog, you can search for all those pieces, and it's searchable, and it's connected, and you can add your own relationships. So it doesn't really need to have an Azure Data Factory in between. You can add a stored procedure connection hub, for example, an edge between those entries. So all of the metadata you have and you think that is required and that is, well, can be used afterwards, just try to push it somewhere into your data catalog.
Okay, that makes sense. There's one question. I mean, I don't know. We don't build Azure, so but his question. Let's try to answer this one. Some countries, even my country government, fearing to store their sensitive data in the Azure or any other public clouds. Microsoft has any plan to implement the B2 government to encourage to use cloud? Or maybe let's put it this way: if I have a manager, right, how should I convince my manager or my team leads to go ahead and move to Azure or public cloud?
That's a really good question, and we have and had those discussions in the last few years in Austria. Austria is some kind of oh my God, we are afraid of the cloud. It's getting better, and what I see, we are getting an Azure computing center, data center in Austria, and that is one huge thing where customers say, hey, okay, the data is stored somewhere near our company. It's not stored somewhere, and that is one thing. And the other thing, there is a huge list of certifications. There is a long list of available certifications around the Azure topic, like security audits and so on. So if you just search for Azure security and data privacy certifications, you've got 2 weeks to read all those certifications. So that is more the legal aspect, but what I often mention in customers discussions is the Azure team. Well, I think they know how to handle huge amounts of data. I think they know how to handle privacy of data, and is, not to offend anyone, is your admin team in your company that kind of high level like the Azure team? That is one of, I know it's kind of, contrary and some kind of
it makes sense.
Yeah. But they know how to really run huge instances of data and data centers.
I agree. I definitely agree. I think everyone is moving to clouds. Some people are a little skeptical, but as you said, it's changing with time. So definitely, I think everything will move to cloud. Whatever we have, I think so shouldn't be any problem. Trust it. As you said, they're kind of the admins.
Yeah.
Any that was an amazing session, Wolfgang. Any final thing you want to plug in before we move to the next session?
For all the others that joined, enjoy the rest of the conference. And Simon, thanks for everything you do. 11 days of work. Get some rest, and thanks.
All right. Thank you, Wolfgang. Really nice to host you again. And I'll see you some other time. Until then, take good care of yourself. And yeah, see you soon. Ta-ra.
See you
Bye.
soon. Bye.
All right, with that absolutely amazing session by Wolfgang, we now move to another session that's focused more on .NET and Azure and time series anomaly detection. We're going to have Marco. Marco is a senior solution architect and a Microsoft Azure MVP. And he says he's not a data scientist in his, no, okay, I messed it up, sorry. So let's, that was his session's abstract. You know, it looks like it's third day and it's day 3 and there's still 8 days to go. Can you believe that? You can already see. All right, so let's welcome our next speaker, Marco. Welcome, Marco. Welcome to Cloud Summit 2021. You are muted.
Sorry. Thanks, Simon. Hello, everyone, and thanks for having me.
Yeah, welcome to Azure. Welcome to Cloud Summit 2021. We're really excited to have you, Marco. Where are you joining us today from?
I'm from, I live in Pordenone, that is in the northeast of Italy.
Mm-hmm.
So, where I have a solution architect in Dintech, a real company that makes solutions, specifically IoT solution for companies here in Italy.
All right, that sounds great. So I already see you're sharing your screen. I'm going to add it to the stream now. And next 25 minutes is all yours. And everyone who's watching on Learn TV, right? On Learn TV, we do not have a chat option. To visit Azure Summit Live website, you there get an option to chat. So yeah, Wolfgang, next 25 minutes is all yours. And I'll see you towards the end.
Okay, so thank you, everyone. Thanks for being here in this session. We will speak time series anomaly detection with Azure and .NET, and this is part 1. And this is part 1 because we will have a second session on September 23rd, and we will go deeper. But I told you next at the end of the session. So I am Parenzan. As I said, I come from Italy, from Pordenone. I'm a solution architect. I have a community here in Pordenone where we speak about these kind of topics. I am an Azure MVP, and these are my profile if you want to contact me after this session. So Simon read in my abstract that I'm not a data scientist. Yes, this is true because I am more a .NET developer. I am an IoT developer because this is what I do on a daily basis. I like to say that I am a one-man band. Obviously, I am a company. I am in a company, and I have a lot of colleagues and with a lot of skills. But sometimes you find alone on working on some topics. Or yes, I have also a background of an individual professional. So my mind comes from one-man band, where you have to handle some topics that you are not very comfortable. For example, data science. Data science is obviously a current topic for these days, and we have to work with. So my comfort zone is mainly .NET. So all my research is about how can I handle these topics with .NET if we can, obviously. So let's introduce a scenario where I have this situation. And the typical scenario where I have this need is an IoT scenario. Things about IoT, things about temperatures. Yes, if you make some work with Arduino, with Raspberry Pi, and you work with some sensor, you play always with temperature. But temperature is a real measure that you need, that you work with on the field. For example, if you speak about real industrial session, industrial fridges in which you monitor temperature. About temperature, because you have a condenser where you have to exchange heat, and you have to monitor if the temperature go away from the fridge in the correct way. So again, it's not just a play. Temperature is a correct measure in the IoT field. So in the IoT field, we have a device, we have a fridge, we have the temperature sensor, and we collect probably with IoT Hub and with some sort of IoT ingestion, we collect data into a storage for following processing. What do you mean? What do you do with processing IoT data? Well, first and foremost, there is the batch processing. That means you collect and then you process data in the following time. You don't do always real-time processing. Why? Because you don't think that you have real-time need to discover some kind of strange things or outliers that can come in your data. Yes, you have always streaming, but you can start from batch. What you can do with that batch data, you can calculate efficiency if you are consuming correctly energy, if your distribution of energy consumption, for example. And this is typically a BI, a business intelligence topic, in which you present a report with your graph and you see the trend. But what about anomalies? Anomalies is something that goes outside the trend. Something that has to be distinguished from the normal trend. Yes, visually you can understand that there is an anomaly, but how can an algorithm recognize automatically that there is some outlier in the topic? And so this is all about anomaly detection. Anomaly detection in time series. That means events that are sequenced in time. So events that are ordered in time and have to be considered as event ordered, because without ordering you cannot consider this. Anomaly detection of a time series make assumption that there is probably the outlier. So the anomaly is something that is very rare. So you can distinguish because it's a value that comes outside from the normal trends, and that is very distant, very far from the normal trends. And this is how anomaly detection in time series works. Why we have to use data science? Because the threshold anomalies, that means a level, using a level upper or under that level distinguish, like for example this second graph. It's not every time this way, because if you look at the first graph that you look here, you see that the thresholds are continuously different, but is that we can say the percentage, we can say the ratio between the normal and the outlier that becomes the anomaly. But this is not just one value over. This value changes every time. And this is why we have to use other algorithms rather than something about threshold. So our topic is how do we implement the process of working with that data to understand the outliers. Again, as I told you, I'm not a BI analyst, I'm not a data analyst, I'm a .NET developer. And we can say we have learned things that this kind of project is inside an IoT enablement project where there is no specific focus on that data. In general, there is no specific finance to find analysis. You spend all the money to implement the ingestion architecture, and then you say, okay, next you have to implement some logic on that data. And in your team, there is no resources about that. So I'm a data developer, and I have to understand if the anomaly are present. And so all my journey has become, how can I become a data scientist with my comfort zone? So let's discover which are the pillars of a typical data science and modern data scientist. First, Spark. Spark is an engine, is an open source engine, is a cluster management platform that allows to implement batch processing, real-time processing that scales because it can work on few data, it can work with big data, so gigabyte, terabytes of data in a scaling and elastic way. So when you work with Spark, you find a couple of scenarios: batch processing and notebooks processing. Batch processing means you create a script, you create a program that you run on Spark. You load the data, the Spark works with the data, and then you obtain your data. As there are notebooks. Notebooks are a tool, an interactive tool, where you can write code. You can write code on the Spark cluster, and then you obtain intermediate data. And you can change your code as you are writing. So you are experimenting, sketching code until you find what you wanted to do, what you wanted to find. So these are two important tools. Overall, notebooks experience is very common. In fact, you have the Jupyter tool, that is the notebook implementation in this web-oriented, data science-oriented world. And then there is obviously Python. There is also Python. Why Python? Because it's simple to start. It is open source. It has a lot of data science tools on that, and so in university and companies, it's quite simple for that to adopt Python. Remember one thing about Python. That yes, when you speak about TensorFlows, PyTorch, you think it's Python. No, there is a library behind that. That is a native library. So the algorithm is not implemented immediately in Python, but is native code, C code, and then you call it from Python. The same way is Spark. Spark is written in Java, so there is a bridge between Python and Spark. So that Python can speak with Spark through Java. And the same is Jupyter. Jupyter is not written, is a web application, is not written in Python, it is written in Java. And this means that also here there is another bridge that is called kernel that allows Python to speak with Jupyter. So this is the scope. This is the scope. This is the background where typical data scientists work. So let's discover which are the tools that we as .NET developer have in our toolbox and we can use. First, in the data science scenario, you have two specific main differentiation: supervised and unsupervised machine learning. So unsupervised machine learning means no labeling, because me as a developer, not a data scientist, not a data engineer, I don't spend time to label the data to understand which is true, which is false, to train my algorithm. I want something automatic. And that's why there are some algorithms. One of these is spectral residual CNN, convolutional neural network, that are implemented, and this specifically was implemented by Microsoft itself, that it works like an automatic training tool. So you as a developer, you don't need to train the algorithm. It trains itself with the data you give to the tool. And this is good because we want to spend the time to work, not specifically to train and then just to work. And this is good for us as developers. So let's speak about specifically the .NET Toolbox and what .NET gives for you as a data scientist. First and foremost, ML.NET. ML.NET is a library like PyTorch, like TensorFlow, with which you can run data science algorithm, machine learning algorithms natively on .NET. You install in your application NuGet packages, and then you can implement this. In fact, for example, in this are all the tools, all the interfaces, all the tools that .NET implements. You see, okay, sorry, the arrow is moved. You see that here we have anomaly detection. So in ML.NET is not only a platform to implement ML algorithm, but you have directly an algorithm, that's algorithm SRCNN already implemented. And then you can already use it in your application. So ML.NET is a good library to implement anomaly detection. And then you have .NET Interactive. .NET Interactive is the support from the .NET framework, from .NET as a scripting to support Jupyter and Visual Studio Code to implement the notebook experience. And so if you install .NET Interactive, you can have a C# kernel inside Jupyter, or you can use notebooks in Visual Studio Code, writing in C#, and also you can write in F# or in PowerShell, for example, PowerShell core. And this is really, really great. And then you have .NET for Apache Spark, that is the same binding that Python has to write code that runs on Spark. And so you write in .NET Core, and this is great. You don't have to learn Python to write code for Spark. And that code can be run not only on your own cluster or on your machine, but you can also run on Synapse, for example, or, for example, on Databricks. And this is very great. And then there is the Azure Toolbox. What Azure gives us to support time series anomaly detection. Time series anomaly detection, the algorithm that we've seen, for example, the ML.NET code that you can write, can be implemented and hosted in Azure Function. Azure Function is a good way to implement anomaly detection that receive the last sample, the time series to process and to understand which are the outliers of that. Then there are cognitive services in which you have different areas, because you have custom vision, you have speech, but also you have a decision area where there is the anomaly detector. The anomaly detector is an out-of-the-box service, is a SaaS service in which you call a REST API, you send the data, and you obtain the output. You don't have to teach anything. You don't have to configure anything. You have just to configure, you prepare a REST request and then obtain a response. Then you have Azure Synapse. Azure Synapse has included inside it has Spark, so you can host your Spark cluster under Synapse, and then you can also write Python .NET notebooks inside Synapse. This is very great. And then you have Azure Data Explorer. Azure Data Explorer is specifically a platform to manage time series. And on time, and you have a custom language that is custom, in which you have specific language features that allow you to understand if there are outliers in that time series. So you can have a specific service like Data Explorer, or if you want, because you are a business intelligence-based skill, you can also use, again, Synapse. Okay, as we will have a more deeper session on next week on the 23rd, let's look at two fast demos for this session. The first one is this one. This is .NET Code, .NET Core code inside Visual Studio, in which you have what? I have a package that you see, it is Azure AI Anomaly Detector. Okay, so you write the console application, or then, as I told you, you can wrap this code inside an Azure function, for example, and you can you just add these few lines of code. You create a service instance of anomaly detector inside your Azure subscription. You obtain an endpoint and a key. You have your CSV file, which you read as a CSV file. You instantiate your client to the service, and then you can have your processing. Let's look at entire detect sample. So you create a request in which you put your points, and then you just have a request, and that's it. One request, one invocation, and then you have your result. This is just a demo code. You can, with this library, you can detect all the outliers of the series, or you can detect the last outlier in the series, because you can think, I have a batch for all the day, give me all the time. I have packages for 15 minutes, half an hour, and you send each half hour. And so you need the last one, and you send incrementally all your invocation. And this is the threshold. Or you can have also the change point, understand where there is a change in your line trend, so you can understand there is a change. Just to look at how it works. Okay, here it is. Prepare the request. I have the points. I have all the points. Just invoke, and then you have your result. Okay, just to demo. Okay, and you have all the time. You have all your sample data. Okay, and then you probably want to represent. I don't have it in this demo, but I will have in the next week. For that, the other demo is this is Visual Studio Code, and you see that I have an IPy notebook. That is a Python notebook, a Jupyter notebook inside Visual Studio Code. And you see that the kernel that is represented is .NET Interactive. What it means that this is C# code, and we can execute some code. Okay, this is how notebook works. You have markdown code that is just text, and you have a line of codes, and you can have a complex line of code about that. Okay, you have tools to represent all of this. Just to show how it works, I clear the output. You see that you can add, for example, a NuGet package. Okay, you see that it is installing, it's downloading from NuGet, the package for Plotly. That is a library that is born in HTML and JavaScript that represent graphs. Okay, download the NuGet using create a random generator, create a functional time series, and then you have chartplot. And this is how data scientist works. It works with notebooks to understand, to explore your data, things that the code that you have looked with the anomaly detector to put inside this notebook. You will see in the next session. But okay, you understand that you can run everything you want that is HTML based inside your notebook and you write in C#. And this is very great. This allows me that I have no Python knowledge, I have no time to spend to learn a new language. I use my C# code, I use my C# skill to write this kind of code. And that's it. This is what I wanted to do. So understand the message is that the .NET ecosystem in data science world is completing. So it is not behind, is far from. No. .NET is ready to work 360 degrees to cover all the topics. Things that C# is Pythonizing since C#7 to work to have all the simple syntax that Python users love. Things that you can host your .NET code on the Spark. Think that you experiment your .NET code inside .NET Interactive. And think that you can host all this code in Azure because you have many services that can run this code to make you data science. So that's it. That was my objective, to create an overview about the .NET, to tell you that .NET is a language that is ready for the data scientists. I invite you the next week on September 23rd to look at part 2, sorry, not part 1, to look at more complete demo in which you will see ML.NET, Azure Function Hosting, ML.NET, and Azure Cognitive Services, and all that code hosted under Synapse and in Azure Explorer. Thank you.
All right, Marco, I think that was a very crisp presentation, I think, right? And I think people have to come on September 23 to see all the hands-on demo, right? All that you have said today. Yeah, so any final thing before we move to the next session?
Again, I like to say that .NET is really a good environment, and so C# is a great language for data science. We have a very impedance mismatch between data scientist and developer, and there is no more impedance, because as you can write Azure code in Python, you can make good data science code in C#.
That makes sense. That's promising something, right? If you can do data science C#, I see ML.NET, right? People have been using a lot these days, right? Community has been very active around ML.NET. Yeah, so Marco, really excited to see your session on September 23 at 7:30 a.m. Eastern Time Zone. Until then, take good care of yourself. We'll see you then, and yeah, have a nice day ahead, and I'll see you soon.
Okay.
Thank you, Marco. Bye. Take care.
Thank you, Simon. Thank you, everyone. Bye.
All right, with that session by Marco, we now move to our next session. Next session is on Azure SQL. I'm just wondering that this is the third SQL session that we are having. There's so many SQL sessions. I believe any event that we do, I think we at C# Corner, we do like 21 conferences in 2021, and we do live shows every day. And I say that we stream 8 days in a week. SQL is something that people really love. It's no doubt we also have Cosmos DB sessions in the summit, but I don't know, people really like to tune into SQL sessions. So the next session is by Silvano. Silvano is a principal program manager at Microsoft. He's going to talk about increased Azure SQL application resiliency with configurable Teddy logic. And before, you know what? I have a book written by co-authored by Silvano. I thought of reading bio from his book, but I cannot read it. It's so big. I'll let him introduce himself. So without any further ado, let's invite Silvano to Cloud Summit 2021. Hi, Silvano. Welcome to Cloud Summit 2021.
Hi, Simon. Nice to meet you. And how are you?
I'm doing great, Silvano. From where you're joining us today from?
I'm joining from just outside of Milan, Italy. And yeah, as you said, I'm a program manager within the Azure SQL team. And although my team is mainly based in Redmond, I'm here in Europe mostly because I can connect more directly with our customers and take part of their big projects on Azure SQL.
Yeah, to be honest, I did think that you're based out of US because when I was looking at on what time to give you this session, I was like, no, Silvano is from US because all your colleagues, right, we have from there. So I was like, then we figure out, no, you're from Europe somewhere. So thank you so much, Silvano, for accepting the invitation. I'm really excited for your session about Azure SQL. And people are always excited to learn Azure SQL. That is what I have learned from this community, that people really want to learn Azure SQL. So I have your screen being shared. Right, your inside streamer. Once you move to your presentation, I'm going to add it. Yes, everybody can see your screen. Next 30 minutes is all yours.
Perfect. Thanks a lot. And so first of all, good afternoon, good evening, or good morning, depending on where you are when you're watching this. Yeah, my name is Silvano. I'm a program manager in Azure SQL, and I'm focusing primarily around the developer experience of application developers writing application against Azure SQL. So this particular talk will be more focused on kind of code development rather than kind of query processing or kind of other fancy stuff that Azure SQL can do on the server side, right? So we will focus on how to write code properly to deal with things like transient errors and issues that can happen while we are running our applications in a distributed fashion within a cloud provider, right? This actually was a problem also in the good old on-prem space for certain kind of mission critical solutions built on top of very expensive hardware and software. But nowadays in the cloud, we will see why this is becoming more and more relevant. And that's why we introduced the concept of configurable retry logic in our Azure SQL client drivers. For now, you will see that on the SQL client, so on the .NET client that we have, specifically Microsoft.data.SQL client. But the idea is to expand this across all our client drivers portfolio to make sure that out of the box you can configure this new capability and make your applications more reliable. So we will take a look at how to do that, some kind of use cases and scenario, and a lot of demos over the next 25 to 30 minutes. Okay. So what are these transient issues that can happen? Well, these issues can happen at different levels, right? It can be a hardware or software failure within the cloud platform itself, can be a networking glimpse, can be your own application, which is busy processing other stuff and cannot accept new commands and new requests anymore, right? So originally, applications were just failing, right? And so that exception was basically logged somewhere and so on. But nowadays, if we want to make our applications more reliable, we need to consider some behaviors within the application that can deal with these capabilities. And just a reminder, Azure SQL, the different flavors of Azure SQL have kind of architecture behind the scenes that are designed to maintain this kind of high availability. And in order to maintain high availability, they need to, for example, reconfigure servers or fail over between nodes and react, to these planned or unplanned situations. Can be a maintenance where we are rolling out a new feature, or can be, as I was saying, hardware failures that happened somewhere. And those reconfigurations are typically happening in few seconds. Usually, you can see, the average is 2 seconds for failover time in Azure SQL, up to 8 seconds. There can be some kind of longer tails that can happen, but This is on average what we see on the platform, right? And the server is emitting specific error codes. If you click on, we'll see on these links on our documentation, you will see the indication of what type of errors can happen or can be treated as transient. And also a reminder at this other link, you will see what is the underlying architecture of Azure SQL that is maintaining high availability on the different service tiers, right? So again, historically speaking, there's been a proliferation of third-party or external libraries to deal with this transient issues problem, right? So the retry from a let's say architectural perspective, the retry pattern is the approach to use, where basically we are detecting if there is a specific error or exception that is provided by the server, and if that is in a list of errors that we consider retriable, basically we are automatically re-executing the original database operation that was failing after, for some times that are typically configurable, and with a given delay to wait for the server side basically to come back in a good shape and be able to execute the original operation, right? And as I was saying, various libraries and frameworks have been created over the years. Some of the most famous ones are, for example, the transient fault handling application block from Microsoft Pattern Practices team. Poly is a popular .NET open source library here, but also failsafe in Java, for example, Tenacity for Python, and so on. Those are all interesting external libraries. The problem is, developers should have adopted those techniques upfront, right? And the reality is that this is not very frequent, right? A lot of existing apps out there are not implementing any retry logic. And even if you are developing a brand new application, it's hard to pick up what is the right framework, what is the right library to deal with this type of errors, right? So what we've been doing is, we thought, hey, why don't we create a retry logic framework within our own client drivers, and starting from the V3 of Microsoft Data.SQL client, which is the official .NET client for Azure SQL and for SQL Server in general. We started basically to create a framework where developers can developers that have existing apps don't need to change anything, just add a few configurations in the config file that specify how the application should react. And whenever you are opening up a new connection or you're executing a command, those retry logic capabilities will pop up in case there is one of these transient issues that I was referring to. But if you are developing a brand new one, within the SQL client, you also find a bunch of new classes that you can use in your own application logic in order to create those different kind of retry logic profiles, because maybe your application is doing a lot of different interactions with the database. Some interactions maybe are just queries as part of a reporting page, right? So you can easily kind of simply retry them every time you have a kind of something which is malfunctioning. Or those operations may be part of a more complex transaction, right? So you may want to wrap multiple database interactions back and forth, round trips, into a single kind of unit of work that you want to retry all together or fail all together, right? So for now, we have shipped this in SQL client, but we are planning over the next 12 months or such to be able to expand these capabilities to all the other major client drivers like ODBC, JDBC, PyODBC for Python, and so on and so forth, right? So expect more in this area. So let's dig a little bit deeper into what this configurable retry logic means. So basically, this feature is made of three main components. So there is a core API, so a set of classes that basically are defining what are the behaviors? So how can I detect that there is a transient error? How, what should I do in case there is one, right? And the second pillar here is we implemented on top of this core API our own kind of default out-of-the-box retry logic provider, which is within, again, the SQL client bits, and we shipped this with some predefined behaviors, right? So you can think about the most obvious ones, like a fixed interval retry type, right? So there is an error, I'm going to retry this after 2 seconds or 5 seconds, and then after 10 seconds and 15 seconds, and so on and so forth, right? Or for example, an incremental one, where first time I'm going to try after 2 seconds, and then after 8 seconds, and then after 30 seconds, right? And so on and so forth. So we created those behaviors as part of this retry logic provider, which is available out of the box. You can reuse it as is in your own applications. The third pillar is a configurable configuration file schema, right? So because we want developers to be able to introduce this capability of retry, the retry logic without changing their application code, we wanted basically developers to be able to just change, add a configuration file to an existing code base, configure a few attributes, and then the application will retry immediately without, writing down your own retry logic into your app, right? So this is these are the main components. If we look at the core API, again, kind of three main components here. The enumerator class is basically the one that is generating this sequence of time intervals, right? That they depend on a given retry logic. The retry logic itself is basically asking the enumerator, hey, when is the next time I need to re-execute that? And it's basically checking that the max number of retries is not crossed, and so on and so forth. And the higher level one is the retry provider, which is basically you can define a retry logic with a given enumerator and attach this to a connection or a command object within your code. Right, so you can see this diagram below that, which is explaining how it works. So let's start talking about some more practical aspects here, like hey, how can I use this in my existing app, right? So if I have my code base available, I can just add a reference, basically replacing, for example, system.data.sql client or previous version of the Microsoft.data.sql client with the v3. Then you need to create a specific section in your application configuration file. So this is an example, right? In this config sections, I need to add these three config sections first that are pointing to these specific classes within my SQL client library, right? So the SQL configurable retry logic connection, which is the section of my retry logic dedicated to SQL connection, so opening up a new connection and intercepting an error there, or the SQL configurable retry logic command, which is instead the portion of my retry logic kicking in when I'm executing a command and I'm getting a transient error back, right? We also are protecting this particular feature, retry logic, with this app context switch, because we want to make sure that developers are not kind of switching on this feature by mistake, right? And start applying kind of retry logic where it doesn't make sense. So if you want to use it in your config file, you have, depending on .NET Core or full .NET Framework, they have a slightly different syntax, but this is the attribute that you need to have app context switch overrides, and the value which is enable retry logic equals true. Right? So once you have this kind of few sections here, you can add two more attributes. One for basically configuring this retry logic on opening up a new connection. And again, you will see you have to specify what type of retry method. This is a fixed retry or as I was saying, you can have an incremental or an exponential one. The maximum number of retries, the delta time between the retries, and eventually a max time where the library will give up retrying on a specific set of errors. Interesting thing, you can also specify your own list of, if you have in your logic a certain type of error, let's say for example a deadlock type of error, which you want to retry and treat it as a transient, you can create a list of error codes here. Those are the SQL Server error codes or Azure SQL error codes with the separated by a comma, and then add your own. Right. So by default we have, if I remember correctly, like 20 error codes that we are considering as a SQL team retryable, right? But now you can add your own if you think again from your logic you want to get more. The SQL command one is very similar, with the addition of you can add this regular expression here, which is basically telling the library what are the authorized SQL condition where you want to basically kick in this retry logic. Right. In this case, for example, the syntax is quite simple. Is only retrying commands that contains a select in the command text. Right. But you can put here whatever you want. You can create even more complex regular expressions that are basically telling the library where you want to retry a certain operation or not. So what are the retry logic attributes? Again, I just briefly mentioned some of them, but you can imagine those are pretty self-explaining. Number of tries, the delta time between, those retries, min and max time, the list of transient errors, as I was saying, and the name of the methods. By the way, I didn't mention that yet, but in addition to the to the default retry provider that we have baked into the SQL client library, you can create your own. You can create your own .NET assembly and basically inherit those base classes that we have, and then create your own, right? Even exotic or complex one. But you basically can define what are your creator methods to create your retry providers, and then you have to set the retry method name here in your configuration file in order for the library to be able to invoke your own retry provider and your own code. Okay, so let's see it in action now. I think it makes sense to do that. I have this example is also available on my GitHub repo. So if you search S Coriani on GitHub, and then you will see the configurable retry logic repo. I have 3 demos here. Let me move to the introductory one. And here I have the simplest data access application that you can imagine, right? So I'm basically, reading my connection string from an environmental variable. I'm just opening up a connection and creating a SQL command and execute the command, right? Which is returning, the version of my SQL Server or Azure SQL endpoint on the other hand, and basically I'm writing down whatever is returning. I also have here in the code tracing kind of a listener class, which will print out a bunch of interesting information during our demo, right? So if I have this application and my server is returning is basically returning an error, let me try this .NET run, and what's happening here is that, boom, the application is basically broken, right? It's giving me back an exception. Of course, I cannot control, when a transient error is popping up. So what I did was I just closed all the firewall ports here, right? So I'm basically simulating one of these transient errors by closing all the ports, and then I will play with opening and closing to kind of simulate what's going on here. But one important thing here is to see is that the default behavior for any application that doesn't have any retry provider is I'm going to try opening the connection and then I'm going to fail. Okay, so let's see if I have this application config file here pre-created, which is exactly what I showed you previously on the deck, and I'm going to rename it correctly as app.config. Okay, so now the .NET runtime, whenever it's starting this application, it will pick up this configuration file and it will start trying to basically re-execute that connection.open method for maximum 10 times whenever there is a transient error, or again, just my kind of fake transient error here, which is the 4615. Again, the a firewall closed, right? Type of error, which SQL is returning in this case. So I'm going back to my window here, and if I rerun this thing, you will see that now. Okay, now you see this is the retry number 1. So we see the retry logic in action, right? So what it's doing is I'm trying for the first time, for the second time, for the third time. Now, while we are waiting here and retrying, let me open up on this other terminal window my firewall for this particular client IP that I'm running here. Right now, we will see that after a number of retries, the application is now responding correctly, right? So I can see the the SQL Server version. So the application didn't fail, even if for the first 3-4 times the firewall was closed, and now it basically is restarting again. So you can imagine, from an application perspective, she was just waiting for the transient error to basically finish, to stop, and the regular functioning of my SQL Server going back to normal, and then the application will continue to run here forever, right? So this is just an example of what it takes to start from a brand new, from an existing application with no code changes whatsoever. In fact, my code is always here, and I didn't change it. And just adding an application configuration file, few configuration attributes here, and the application will immediately be able to respond to some of transient errors that I'm specifying here in my configuration file. Okay, so this is just one simple demo that I have here. Again, if I'm instead writing a brand new app, I can again use those base classes that I have in my default retry logic provider and start using it to make our applications make my applications more reliable, right? So what I have to do, typically, I'm defining one or more SQL retry logic option instances that are describing what type of retry behaviors my application should have. Then I create one or more SQL retry logic base provider instances. And again, why more? Because within my application logic, I may have different type of behaviors that I want to apply to this type of transient errors, right? So that's why I may need one or actually more, right? And let me go ahead and show you what this means from a code perspective, okay? So I'm now showing this new app folder here where I have again, my app. What I'm doing here is, as I was describing, let me expand this a little bit, make it more readable. So this is the equivalent, as you can see, of that attribute in my config file, right? So where I'm basically specifying, hey, what are my retry logic parameters, the number of retries, what is the gap between retries and so on, and then I'm instantiating this retry logic based provider, right? By creating, in this case, a fixed interval type of retry provider, but I have also all the other types available here. And then I'm just assigning to my connection through the retry logic provider property, I'm assigning the retry logic provider that I just created here, right? And out of the box, my application for the connection.open method will start retrying with the logic that I described here in case there is a transit error. One interesting thing also here, you can see you can intercept an event, right, that is happening every time there is a retry happening, and then you can do things like, for example, logging, log it in your application logs or do whatever you like. But basically, in your code, you can start interacting with the retry logic that you have created, right? So this is how, for a new application, you can leverage this. As I was saying, you can also create a custom retry logic provider. Some examples could be, for example, I don't know, I want to have a pattern of retry operations that is different than what we have in the default provider, right? Or I want to have, the ability within my own code to define for different areas or different situations in my applications completely different behaviors. Well, again, to do that, you just you implement these three interfaces in your code base, and then you can write your own logic, and again, assign the logic to your connections and command instances, and this will work. You will see an example in our documentation available at this link, but I can also quickly show you what it means to create your custom provider. Basically, as you can see here, I have implemented a number of my own custom classes, basically a retry logic one, a provider, and an enumerator, as I was saying, right? So the enumerator, what it's doing is basically just defining. Here it is, creating a new interval mechanism, right? In this case, I'm just returning an interval which is 4 minutes. Kind of meaningless, but just to show how it is. And what I'm doing, I'm implementing this particular interfaces, which is the base enumerator. Same thing for the retry logic, and the retry logic, for example, here I hard-coded the maximum number of attempts. Not a great idea, but again, just to show you that you can create your own logic here, again implementing this base interface, and then the provider itself here is the one basically applying the logic to a certain number of exception numbers and so on, right? So nothing really super complex here, but just make sure you understand what you're doing when you're creating your custom one. And again, once you have it, the usage is exactly the one of the base provider. You are just creating your custom provider and assign it to connection or to your commands. Okay. So, and again, you will start from that sample in our doc, and that will help you. So again, just to recap, 3 main kind of use cases for the configurable retry logic. If you are creating a brand new cloud native application, please make sure that you consider retry logic as part of your kind of default type of behavior. This is not true for Azure SQL. It's true for every service-to-service interaction in the cloud. Other libraries, client libraries, like for example Azure Storage client library, has retry logic baked in. Service bus has retry logic baked in, and so on and so forth, right? So make sure that you consider this as part of your normal kind of development cycle. If you have existing apps that you're migrating to the cloud, as I was showing you, by just adding an application configuration file and basically leveraging the the latest versions of the SQL client drivers, your applications will automatically become more reliable by reacting to those transient errors. Right? And another scenario which is very, very important, Azure SQL database, sorry, has this serverless service tier, right? Where you can save money by auto-posing an instance that nobody is using for a certain interval of time, right? Now, if you have an application which is which wants to connect to a SQL Server serverless instance that has auto-posed, right? The first operation will always fail because the way you are basically warming up, waking up an auto-posed instance is by trying to connect the first time. Now, with configurable retry logic, you can create your app config file that says, for example, hey, try for couple of seconds, and then if it's failing, wait for the SQL Server serverless database to wake up. So you give it a given amount of kind of retry time, and then the next time that the application will retry, the instance will be up and running. Right. So this is a great simplification again for existing apps that wants to deal with serverless. Okay, so that's all. As a next step, as a kind of recommendation for you, please take a look at the configurable retry logic doc in our public documentations. This is the first link here. There's also a MS Learn course around Azure fundamentals that can help you to learn more about Azure SQL. And in the well-architected framework, which is another area of our Azure documentation, you can take a look at this section called Optimize for Scalability and Reliability and retrieve a lot more interesting information on the subject. Okay, and that's all from my side. Ooh.
Wow, Silvano. I mean, I was looking at the session, everything went over my head. I don't get a lot of stuff. People are talking sort of demo and how to avoid pitfalls, some of the best practices. So definitely people watching your session now and once we archive it, they'll definitely get to learn a lot. I have a book written by you, right? I have not gone.
Thanks for the free spot.
I've not gone. I'm on chapter 5 now, but this is a more like a hands-on book, right? So I really love this one. Yeah, and I've hosted almost everyone who has co-authored this book, and I say I really love the SQL team. They're very active in their community, and you guys and girls have been doing absolutely amazing job. We have all right. Let me okay. Let me. Okay, we have a question. By Joe is asking, will this configurable retry logic also be available in the MS JDBC driver?
Absolutely. As I was kind of mentioning at the beginning, our goal is to implement the same capability across all our kind of major drivers in our portfolio. So JDBC is actually next in line, as it's very similar from an implementation perspective to the .NET one, right? But we are also working on ODBC, which is still very much used across a bunch of different scenarios. The PHP one, tedious for Node.js. So the idea is make sure that all programming languages and frameworks will be able to leverage the same capability.
All right, that sounds great. So stay tuned. I think it will be released from. I think you also have some monthly newsletters, right, where people can actually go in and follow up.
Correct. Yeah. So there is a Azure SQL a monthly. There's also a live show actually on YouTube, which on a monthly basis is presenting all the news, all the product news, and interesting documentation or samples and so on. So I definitely encourage people to take a look at the Azure SQL account under YouTube. That's probably the most interesting one.
Yeah, I know the Data Expose show, right?
Exactly.
That's one of the very famous one that I see mainly happening every week. So yeah, I think Silvano, that was great. Any final thing you want to plug in before we move to the next session?
No, just again, think about your application reliability. It's an important factor in the cloud. It's important that you consider that up front. But even if you can't, we are working to make sure that you can just enable that with some configuration options and make your applications more reliable.
Wow, thank you so much, Silvano. That was absolutely amazing session. We would love to have you back next year or in some other live shows and conferences that we do. Thank you for accepting the invitation. And yeah, have a nice day ahead and see you soon.
Thanks, Simon. It would be a pleasure. Bye. Bye.
Bye. All right, so here's a quick and very important update that if you're someone who's watching us on Learn TV or on Microsoft Developers YouTube channel, we're going to drop it from there because they have some other live show schedule. And in fact, Silvano was telling today we have a data exposed episode live show. So yeah, please watch that live show, but don't go away from this Cloud Summit. So we're gonna drop from Learn TV and from Microsoft Developer YouTube channel, but we will come back in after about 2 hours. And then you will be able to hear Kyla Cinnamon giving her keynote and Christopher Harrison talking about static web apps. So in the count of 3, and yeah, please switch to Azure Summit.live website where you also get a chat option. On Learn TV, the chat option is not there. I don't know why they didn't enable it. So in the count of 3, 2, 1, we're going to drop from Learn TV now, and we're going to drop from Microsoft YouTube channel now. All right, now we move to our next session. That next session is by one of our partners. That's by PagerDuty. I'm going to play a quick promotional video. That's important, and then will be followed by one of their developers who will take you through through their applications or the product. So enjoy your next 30 minutes with PagerDuty.
Life in operations. It's a mix of planned and unplanned work. Operators frequently find themselves getting interrupted with an endless stream of tickets, often for doing the same things over and over again, and those tickets are often escalations to yet another team. Resolving these tickets leads ops teams to searching documentation and runbooks, looking for steps to complete routine procedures. Hopefully, the docs are up to date and the operator has access, and they don't make a mistake. And of course, that the business can afford to wait. Wouldn't it be great if there was a better way? What the operators really need is their runbooks to be automated. Here's where Rundeck can help. Rundeck by PagerDuty is a leading solution for runbook automation. Customers use Rundeck to delegate automation to the right people in the organization. Now users get self-service access to operations that previously only subject matter experts could perform. Rundeck automates IT workflows and processes, replacing the previously manual procedures found in documentation. Rundeck doesn't replace existing automation. It makes existing automation, scripts, and commands more secure, auditable, and safe to run. Rundeck is a central hub for automation, connecting key tools and infrastructure in operations workflows. Rundeck helps teams resolve incidents quicker, avoid interruptions, and get more done, all while ensuring things are locked down and remain compliant. First responders are empowered to resolve incidents themselves instead of escalating, minimizing disruptions and reducing outage time. Operators become more productive. Developers stay focused. IT users can solve problems for themselves with the click of a button. Rundeck customers regularly see 60% shorter incidents, escalations cut in half, and 15 to 20% increase in productivity. Sign up for a demo today.
I'm Andre from Content, and today I'll tell you how to build fast and secure websites with Jamstack using .NET and how to deploy them to Azure Static Web Apps. Let's start with Jamstack. What is Jamstack and which benefits it actually brings to .NET developers? Jamstack is referred to by many names, including static sites, pre-generated sites, and so on, and people often think that they can only be generated using JavaScript and JavaScript frameworks. But the truth is, you can actually use any technology or framework you like. The idea is, you take content, you take templates, and generate as many files as you have content items. Those generated pages can sit on any static file hosting, or they can be distributed via global content delivery networks. Now, Jamstack doesn't care how you build the static files, as long as the output are the static files. But if you're working with .NET, you can use static site generator built for .NET, which is called Static. It provides a rich set of features and offers integrations with many tools, including the headless CMS content. So you don't need to worry about solving boring tasks like putting all the things together and configuring them, but you can start working on the actual website right away from the start. So how does Static work? Static comes with the concept of documents, modules, and pipelines. Document represents any source data item. In this case, it can be graph, it can be text, it can be user, or any other type of entity that is somehow represented on your website as content. Module, on the other hand, is responsible for transforming the documents, your data, into an output. Here you see that we're trying to transform textual documents into a single XML file that can be later imported by visitors of your site into their RSS readers. And finally, pipelines are responsible for chaining modules. You see, modules are typically reusable pieces of functionality. So in order to generate a PDF file like we're trying to do on this slide, we first need to resolve images and links, build the underlying structure in HTML, and only then we can convert the content into PDF. So pipelines are used for chaining modules and defining the order of modules. Now the documents can come from various data sources. In this case, we're getting the content from the headless CMS Kaneko content because it features integration with Static and can provide all the content items from the cloud as documents. The way how it works is that Static on every build fetches the content from the headless CMS and executes all the pipelines it can find in the project. The output of every pipeline can vary, but in most cases it represents a file that is generated into the output bundle, into the bundle that is then deployed to the static file host. But let's get to code. Let's get to see how the static implementation looks like. So first of all, let me show you the code repository on GitHub. You see the repository does not contain only the static implementation, including the solution file, but it also contains a package called content.zip that you can use to import data into the headless CMS. What you'll need for that is first account on the headless CMS, so you can go ahead and sign up if you haven't already. And once you have an empty project, this is the screen that you'll be looking at. We're going to import the content using Kaneko Content Template Manager, and for that we're going to need two API keys, which you'll find under Project Settings and API Keys. Now, the content package is in the repository, so we can go ahead and import the content using the project ID and the API key for Management API. You first need to activate it and then copy the key. Well, we also want to publish all language variants after import so that we can directly work with content. Unpublished items are not present in the delivery API that we're used to consume content in the static project. So I'm going to prepare for import and then import the data into my project. And once this is finished, you can go back to the project in the headless CMS and see all the content items are here. Now, this is the only thing we need to do so far in the headless CMS. Otherwise, we're just going to consume the content via the API. And let's take a look at how the solution looks like in Visual Studio. You see there's only one project, kentico.content.static.lumen, which contains all the code files of the static site implementation. Now, I talked about documents, modules, and pipelines. Here we're going to take a look at the pipelines because there's only a single module. The fact that static framework is very rich means that it comes with a lot of modules out of the box. So you typically use the ones that already are in the framework rather than creating your own. So what we're going to look at are the pipelines. Now you see that this website is quite advanced, or it already has a lot of use cases that need to be handled. So that's why there are a lot of pipelines. We can take a look at the homepage pipeline, or the home pipeline actually, where you'll see that each pipeline consists of three things. It's the input modules, process modules, and output modules. Now I'm going to talk a bit more about them when we create a new pipeline here, but just so you know, the input modules actually define the documents that come into the pipeline. In this case, it's based on a dependency, so we're not getting any extra input here. But when we look at the posts pipeline, for example, you see that the input modules are actually getting data from the headless CMS. So that's the new content article delivery client. This actually gets all the articles from the headless CMS. This is the headless CMS SDK class. Now here you can define what kind of content you want to get in the pipeline. But I just wanted to show you this so you know how the documents actually make their way into the pipeline. So coming back to the home pipeline, you see that here we start with process modules, and the process module actually takes all the documents from the posts pipeline, it paginates them, and it reads index.cshtml file, which is essentially a razor file that defines the template of the output page and renders the razor with the data that we prepared. So when we look at the index.cshtml file, you're going to see that this is a markup for a main page. So there is some content. There we display the articles, and that's it. There is nothing else here. Now let me build this site. I'm going to generate it. I'm going to show you how it looks like so that we can add some functionalities to it later. So I'm going to run the site using .NET run and a flag preview so that we also get a server that serves the files. By default, if you just hit .NET run, it builds the site and it adds all the files in the output bundle that's under output folder of the project. If you add the flag preview, it will also start a web server that serves all the files that are within the output folder. Now let me show you that. So let's try it, .NET run with the flag preview. Okay, and now we can access the website under localhost and port 5080. So you see this is the generated website. It's a typical starter that we use for also other technologies. Here you see that there is an author, there are some articles here. You can also switch to night mode, and there are some additional items in the menu. When we go look at the article, there are also tags and categories that are just used to list all the articles in the specific category or that feature the same tag. Right now we have 5 articles on the website. What I want to do is, oh, this is not running anymore, okay. What I want to do is generate some articles as PDF files and offer them for download. So whenever a reader comes to the page, they're able to download a PDF file with the content. Now, in order to do that, I'm going to first adjust the content model on the headless CMS side so that we have a checkbox there that the author can decide whether the downloadable version should be available or not. So to do that, I'm going to jump into content model and I'm going to adjust the article content type. I'm going to add here a single multiple choice field. Let's add it under title and call it downloadable. Now we're not going to make it required. It's going to be checkbox. And the option is going to be yes. And let's go back into content. Now here, I already have the draft version, so I'm just going to click yes, downloadable yes, and publish the item. I'm going to do the same with one more article so that we have at least 2 articles that we can work with. Upgrade it to Gatsby v2, for example. I'm going to create a new version, mark it as downloadable, and publish. Now it usually takes a few seconds before the fresh data make it to the CDN, but then we can work with it in the project. Now, when we change the content model and underlying content types, what is going to happen is that our models that were generated from the headless CMS are no longer in sync with the headless CMS. So let's take a look at the article. You see that there are some additional data that we need for our site, but the article.generated.cs is actually one-to-one what we have in the headless CMS. So you see that there are some code names and some properties that actually correspond to the headless CMS content type. Now what we can do, we don't need to change it directly, but there is a tool that we can use to regenerate everything. It's using content model generator and connects to the headless CMS, downloads all the types, and actually regenerates the model classes. So I'm going to run this. And you see, once the content model generator runs, it rendered 16 content type models. So let's take a look at the article generated. And you see that there is a new enumerable multiple choice option downloadable. So we can use this to define which articles are going to be generated into PDF files. Now, in order to do that, I'm going to create a new Razor view, or I already created a new Razor view. So we're talking about articles, right? Articles are rendered using the post.cs HTML. So you see there is some markup around the article, and there is the publish date displayed, some code names and so on. There is the raw content rendered. Now for the PDF file, we obviously don't care about all the other attributes here. We only care about the specific content. So that's why I already created a new PDF post.cs HTML Razor view that only contains a bunch of HTML elements that make the content look nice, and displays only the raw rendered content. Now, before we can generate the files into PDF, we need to create a new pipeline. So I already went ahead and created a file called posts PDF pipeline. And you see it's completely empty. It's a single pipeline that contains input modules, process modules, and output modules. And the way how we're gonna handle this is we're gonna, for every article, we're gonna call an online service that is capable of transforming HTML files into PDF, and we're gonna get the file back and store it on our local. The input module is going to contain only a single line, which is going to be getting the content from the headless CMS, and we're gonna use delivery client. You see that we have the delivery client injected here in the pipeline, which is handled by the integration of content and static. And we're going to use with query and use new depth parameter 1, which instructs the SDK to get us not only the article, but also the linked items in the first depth. In this case, I'm doing it so that I get also the author object and get the author's name. That's the only reason why I'm doing this. And actually, there's going to be another line. I'm just going to copy it over from another pipeline that is going to set the destination. In this case, we're actually saying where the PDF file should be stored. So in my case, I'm going to store it in the folder PDF / the name of or the slug of the article. So the same way we use the slugs to display the articles on the website, we're going to use the same path, but we're only going to store it as a PDF file. And that's all. That's all we need for the input modules. Now the output module is going to be very easy, and it's going to be pretty much the same as for every other pipeline, and it's going to be only new write files. This is a module from static that takes all the documents that you provided to and stores it as physical files on the drive or in the output bundle. So that's how we're going to set the output module. And in the process module, we're going to have to take the HTML code, or we're going to create the HTML code and generate it using the online service into PDF. So I'm actually going to copy this code over and just go and explain every single step. So here we go. The first thing we need to do is merge content. What merge content does is it loads the Razor view from the file specified and uses that as a template. So we're going to use that. We're going to read the file from the PDF post CSHTML. Now static automatically goes into the input folder for these types of files. So you only need to specify the name of the Razor view, and it's going to use that. The next thing is we need to provide a model for the Razor view. So the Razor view contains a model that we use to display the data, and here we need to generate the model. So I like to refer to pipelines as some sort of controllers. In the controller, you would also get the data from a service, from a data layer, and process the data so that it looks nice for your views. This is the same case. Here we're getting the Razor view, we're getting the data, and the data are coming from the articles that we just got from the headless CMS, right? So this is going to be repeated 5 times. And we're going to render, or we're going to create the view model. So we're using the post view model, and we're providing the article model here as the basis. And we're also creating a new site metadata object with the author of the article. That's because the layout that's around the whole PDF post view requires us to have an author there. So we're going to just provide it, and it's also required by the post view model. When we look at that, you'll see that there is an article and site metadata. So we need to provide both of these. And once this is done, we can actually go on with the conversion of the documents into the PDF. So what you see here is we're waiting for get content string async. This means we're actually waiting for the previous module. So you see this is render Razor, so we're actually combining the content with the template, and we're waiting for it to do its magic and give us the content string async. So here we actually get the whole HTML output of the view. So this would be something that we would store in the HTML file, but in this case we want to generate a PDF. So we only take the content and we call the online service. So we're instantiating the HTTP client, we're providing the HTML and API key, and we are calling the API of HTML to PDF.app service. That is going to make sure we get the PDF as a response. Now you see that this is just the data JSON, so we need to convert it into a data format that the service understands, and we send it as HTTP content. The response, if that is actually a status, there is a success status code, the response gets translated back into a memory stream, and the memory stream we can then turn into a static file. So here you see that the context, this is a context of the static framework, lets us create a document, and we only provide a source stream, so that would be here. We provide name of or identifier for the document, and we actually say that the destination file will have extension with .pdf. We also set up the media type, and we return the iDocument array with only this single document. So you see, we actually created a document, we processed it, and then we return the end of the pipeline, the end of the module chain, only returns the new PDF document that was created using static. And once this is all done, the process modules is done. We go into output modules and we only write the files. And that's it, really. So all of this makes sure that we get all the articles as PDF files. Okay, now you see that the posts PDF pipeline is here. So we got 5 output documents, so we should already have the PDF files generated. Now let's take a look at the output folder. So this is the project, and here we can take a look at output, and you see that there are PDF files here. we have 5 PDF files currently, and when we open some of them, you see it doesn't look nice because we didn't add any style sheets there, but it's the content. And if everything went well, we should also see images. So let's take a look. This is some other document, and we also see images here. Now there's still one thing left to be done here, and that is incorporate the downloadable checkbox into our pipeline. So we don't need to actually generate all the PDF files, but only the files of content items or of articles that have this checkbox set to yes. Now we can do that by limiting the number of content items that we get from the headless CMS based on the downloadable checkbox. So we can adjust the with query here, where we have the depth parameter. We can also add here contains filter. Contains filter because we're using a list. Yeah, there can be multiple options, and we are looking only for the single one. Now here we need to type elements and add here the code name of the element. So in this case, it's going to be article.downloadable codename, and we are looking for a value yes. Now let's try to run this and see if we only get 2 PDF files generated. So I'm going to build the solution and run it. So you see the post PDF pipeline here only got 2 input documents, which is what we expected, and we should have only 2 files generated as PDFs. Okay, so you see this is the PDF folder. We only got 2 articles here. Now the last step is to actually adjust the post razor view so that we can get the download button only for the articles that have the downloadable field set. So we can add a link here right after the all articles. And when we adjusted the razor view, we can run the generator again and see if we actually get what we are looking for. So I'm going to build it again and run the build again. And you see that the server is now running at the same address as before, so we can take a look at the website. And when we look at one of the articles that is actually downloadable, is marked as downloadable, we should see the link here, download PDF. And you see that the link is not 100% correct, but we should be able to get that up and running. And when we look back at some article that is not downloadable, we don't see any PDF file there. So this is how it works. And now let's take a look at how to actually deploy this website into Azure Static Web Apps. So first of all, I'm going to take the whole code base, I'm going to deploy it to GitHub repository, and I'm going to make a cut here. Then we're going to take a look at how to connect the GitHub repository to the Azure Static Web Apps. So now we have all the code in a GitHub repository, so we can go ahead and create a new Azure Static Web App on the Azure portal. So I'm going to create a resource. Let's look for Static Web App and create one. So first of all, we need to provide some project details like a subscription and resource group, and then name our new static website. So let's call it Static Lumen. I'm going to use a free plan, and because I'm in the Western Europe, I'm going to select the Western Europe data center. Now we obviously want to build the website based on code repository in GitHub, so I'm going to sign in with GitHub. And select the repository that I just created. That is static starter content lumen Azure. Now the branch is main, and we need to provide some build details. Now, if you're trying to deploy a site based on Gatsby, Vue.js, and others, it's easier because there are already presets available. In case of static, we have to create our own. So we're going to go with custom. And I'm just going to delete all of these. Oh, this is a requirement. All right, so let's keep the slash here. But I want to explain to you what is actually happening here. So the static web apps is just the deployment place, right? You can only put the static bundle onto this host. So what this is actually going to do is going to create a GitHub Actions workflow that will be responsible for building your website. And once the website is completely built, there is an action that will take the bundle and deploy it on the Azure Static Web App. The important thing here to know is that before that actually happens, before the deployment happens, and once the static website builds, the whole app is in the output folder. So here it says application, and the information tells you location of your application code. Yeah, the slash represents the root of your app. But in this case, the app that we want to deploy is actually the already built app, the output bundle, which is in the folder output. Yeah, so this is a bit misleading. So I'm just going to put here output and leave the rest as it is. Now, when I click review and create, it's going to show me the review. Then I'm going to create the resource. And once the resource is created, it's going to create the workflow on the GitHub repository side. Yeah. The problem is it doesn't know that we're using static, so we're going to have to adjust the GitHub action. Now, the deployment is complete. When we go back to our GitHub repo, we should see GitHub workflow. And there is the workflow created by Azure Static Web Apps. And we're going to change this a bit because you see there is no information about .NET. And we first need to run .NET restore, .NET build, and then we need .NET run, right? So I'm just going to go ahead and edit this file. I already have the right one, so I'm just going to copy and paste this. Now you see what happens here is on the build and deploy job, we are invoking .NET version 5.0. We're running .NET restore, we're running .NET build, and we're running .NET run. And once this all happens, we get the output bundle in the folder output. Then we can run the Azure Static Web Apps deploy, and we tell it that the application is in output. Yeah. All right. Now let's commit this file. And just remember that when you do the same, there are two secrets, this one and this one. Those are the same, but they have a unique identifier. So you have to actually wait for Azure to create this file so that you know how the secret is called. And you need to replace these secrets with the ones that you have in the fixed file. Now, when this happens, we can go back to actions and we can actually see the build happen. So you see that this is the latest one. It's going to take about 2 minutes. So I'm going to fast forward here and we're going to see the result. All right, so you see that the build went through. Let's switch back to the Azure portal. You see the deployment is complete. And when we go back to the overview, we can go to resource. And now we can browse our new app, which is here. And you see, we can go ahead, open the articles, everything is working. Obviously, the PDF files still have the wrong links, but they should all be there. So this is how easily you can deploy the static app using the GitHub Actions to Azure Static Web Apps. And that's the end of this use case. So I hope you enjoyed the presentation. Thank you for your attention. If you have any questions, feel free to talk to me either on Twitter or take a look at the articles on my site. If you're interested in the headless CMSs and in content, there is a QR code that will give you 2 extra months of a full feature trial. So feel free to use it to sign up for the headless CMS. And you will find all the codes for this sample and for the GitHub action workflow on my GitHub, which is github.com/ondramas, the same handle. I'm using it everywhere. So thanks for your attention, and I hope to talk to you soon.
All right, so that was a session by one of our partners, Content. So definitely go ahead and check that out. So people are saying, thanks, Ambarish, really useful session. So what we're going to do now, we still have about 5 minutes for the next session. That's by Igor. That is serverless Angular apps with Azure functions. We're going to take 2 minutes break and we will be back. You can go ahead and grab a cup of coffee or a tea, and we'll be back in about 2 minutes. So until then, here's a commercial break.
Script Runner, the #1 for PowerShell management. We get it. You were hoping that PowerShell would save your day, but you figured out that it is not user-friendly for non-experienced colleagues. Managing the increased demand on IT is a growing challenge, and running scripts manually is still very time-consuming and complex. Welcome to Script Runner, the #1 for PowerShell management. Script Runner runs on PowerShell scripts. It combines everything you need to efficiently manage and automate your complex IT infrastructure. With Script Runner, you'll be able to make it easy for your team to perform administrative tasks without any knowledge of PowerShell, have a transparent overview on all PowerShell activities, and most importantly, free up your IT resources for more relevant tasks such as innovation and development. Download your free trial now and unlock the power of PowerShell.
Life in operations. It's a mix of planned and unplanned work. Operators frequently find themselves getting interrupted with an endless stream of tickets, often for doing the same things over and over again, and those tickets are often escalations to yet another team. Resolving these tickets leads ops teams to searching documentation and runbooks, looking for steps to complete routine procedures. Hopefully, the docs are up to date, and the operator has access, and they don't make a mistake. And of course, that the business can afford to wait. Wouldn't it be great if there was a better way? What the operators really need is their runbooks to be automated. Here's where Rundeck can help. Rundeck by PagerDuty is a leading solution for runbook automation. Customers use Rundeck to delegate automation to the right people in the organization. Now users get self-service access to operations that previously only subject matter experts could perform. Rundeck automates IT workflows and processes, replacing the previously manual procedures found in documentation. Rundeck doesn't replace existing automation. It makes existing automation, scripts, and commands more secure, auditable, and safe to run. Rundeck is a central hub for automation, connecting key tools and infrastructure in operations workflows. Rundeck helps teams resolve incidents quicker, avoid interruptions, and get more done, all while ensuring things are locked down and remain compliant. First responders are empowered to resolve incidents themselves instead of escalating, minimizing disruptions and reducing outage time. Operators become more productive. Developers stay focused. IT users can solve problems for themselves with the click of a button. Rundeck customers regularly see 60% shorter incidents, escalations cut in half, and 15 to 20% increase in productivity. Sign up for a demo today.
Hi everyone, welcome back after a quick short commercial break. We have had amazing sessions in the first half of Cloud Summit 2021. We did talk about Azure SQL, we talked about Azure Cognitive Services, we've talked about pod services, we did also talk about Azure and .NET, we did talk about Azure Purview, and going forward, we're going to learn about serverless Angular apps with Azure Functions. So before we hop into the next section, I have a quick announcement to make. As you all know, we have contests going on. We have 3 contests going on. The first one is a live comment contest where whenever you drop a comment or ask a question to the speaker or share your thoughts in the live chats and use #CloudSummit hashtag, we go ahead and pick a random winner using a tool. That is the first contest that we have. The other 2 are LinkedIn and Twitter contests where you take a screen grab or selfie or be creative in any way and tag us on LinkedIn and on Twitter using the hashtag #CloudSummit, and our handles are @CloudSummitLive, and that we pick winners towards the end of the day. But I think it is time, we have time about a minute before we start with the next session. So we're going to do a quick giveaway of the live comments. Let me share my screen. So here's the hashtag that we want you all to use it when you comment. Just the hashtags are not the valid entries. So let's go ahead and do it. We have about 33 entries. All right. So Alan says, is the current schedule on the website up to date? I know, Alan, we are running a little 5 or 10 minutes fast. And I think a speaker couldn't make it today. So the previous session that you just saw was the replacement of the session by Yorbi. So yeah, so it's updated. It's exactly updated. It's just that we are running 10 minutes fast today. So let's go ahead and quickly see who's going to win it. Are you guys ready? In the count of 3, 2, 1, let's go. I need to add some music in the background. Let's see who wins it. No, Microsoft developer, you cannot win it. All right, Zaim Ziad, congratulations, you win Cloud Summit Swag Kit. Take a screenshot of this and drop us an email at simon@azuresummit.live. You can find the email on the Azure Summit Live website, and we're going to ship you the Cloud Summit Swag Kit the next month because this summit is 11 days. So we need some time. Having said that, the next session is by Igor. Igor is going to talk about serverless Angular apps with Azure Functions. So without any further ado, let's invite our next speaker on live. Hi, Igor. Welcome to the Cloud Summit 2021.
Hi. How are you?
I'm doing great, Igor. For where you're joining us today?
No problem.
So you're joining us from Europe, or you're joining us from US?
Yes, for Europe. Actually, I'm currently in Belgrade, Serbia, Europe.
Okay, yeah. That's great. So what time is it? Is it like evening or afternoon?
Afternoon. It's actually 4:30 afternoon.
Okay, all right. So after you complete this session, you should go ahead and some hang out.
Okay.
If COVID
Thank
is okay. Igor, I think we have plenty of time, right? So I already see you're sharing your screen. I'm going to add it to the stream now. Maybe you want to click on that StreamYard height, pop up what it says. Yeah, on the screen.
Yeah. Basically, this topic is about it's like a short course or short session how to create a simple JavaScript application. In this case, Angular, and how to connect it to Azure functions to the cloud. So basically, I want to aim today to show how Azure functions can be useful for development, and to show what is serverless in a few words. So basically, before I start, I want to present myself. My name is Igor. I'm working from Leversys. It's a British-based company in fintech industry, and I'm mostly oriented to Microsoft technologies. So this session reason for this session is just let's say some passion to Azure services and the whole that ecosystem. Okay, let's start today's session. What is plan? Actually, we will talk about serverless in general, just to say what is serverless, what can be used, what is different than classic systems. Then we will talk about Azure functions, what they are, Azure functions, what can be used, and so on. And at the end, we will show how to connect Angular application with Azure function, and how to make basically pure serverless application without backend. So let's start. I will just this. Yes. Okay. Basically, serverless is not unknown term. It exists before in some other forms, but now it's relatively popular term because some biggest providers, cloud providers like Amazon.
Igor, I'm really sorry to interrupt. I think you're not in the presentation mode. You are in the you're in a different mode. Yeah.
Is it okay now?
Yeah, it's okay now. Yeah.
Okay, I will keep it in this way, no problem. Okay, thank you. So serverless is not a new term. It existed before, and it got in popularity after let's say a launching by few biggest cloud providers like Amazon, Microsoft, and Google. Sometimes we will see functions as a services, which is basically the same thing. And serverless, to be honest, serverless is not the best term for this, because it suggests that you don't have server. Actually, you have server, but server is running on the cloud. You don't have server on premise or in some other forms, but it exists. Which is basically better term is functions as a service. The main goal of serverless was moving to user experience and focus on application, not infrastructures. So we just want to let's say don't care about infrastructure and just focus to client app, or if you use combination of classical application and Azure deployment application, in that case we will be some in mixed mode. But however, we don't want to care about infrastructure and the resources, and we will have better pricing and so on. So main focus actually is just to work on user experience and not see to the resources. Pricing is actually very important here, because if you go to serverless architecture, you will see your pricing will be based on actual amount of resources, which means, for example, 1 month you have high traffic, next month you have low traffic, your invoice next month will be significantly smaller, which is not case in classical, let's say, on-premise architecture systems. So also other advantage, let's say, of serverless access is the process of deploying is much easier, which is obviously also it's not necessary to use serverless code only in serverless mode. You can combine it with traditional styles like microservices. But of course, we can writing them to be purely serverless. Okay. Let's summarize this part. In short, we have better scalability, basically more time to go to user experience. We have better infrastructure stuff like better latency, decreased cost, easier management. Of course, in fastest time for deployment. Of course, there is some downside. If you build application this way, you are oriented to serverless architecture, which means you cannot put architecture in architecture plan whatever you want. You need to adjust your application to the serverless and cloud architecture. So basically, that's some kind of downside. Debugging is not so easy. Of course, we have some tools on Azure. We will find what we need, but it's not the same way as you work on premise model. And at the end, there is dependency in hosting provider. Imagine you want to move your application, your functions actually from Azure to Amazon, for example. It's not so easy. So basically, we have a lot of advantages here and a few downsides here. It's in my opinion, number of advantages is much bigger than downsides here. So it's let's say a great way to go. Also, I want to share a small definition I found somewhere. What is serverless? Serverless is someone else is responsible for this service going down. Actually, is the best definition I found it before, until now. Okay, let's move to and tell a few words about Azure serverless, because I talked about serverless in general. And what is Azure serverless? It's Azure implementation of serverless ecosystem, and in some way it responds to Amazon Lambda, because Amazon Lambda functions were launched at some point in time, and this is some kind of response to them. Also, Azure serverless has support for various languages. Okay, the list is not endless, but the main languages like C#, like Python, like JavaScript, and so on are supported. Also, it's important to understand that Azure Functions is just one of part of Azure serverless ecosystem. Today we will talk about functions, but there is a couple other things which is included in that ecosystem. Okay, let's focus now, before we go to the code, let's focus now to the Azure Functions themselves. Basically, you can describe functions as a piece of code which can be triggered by different event, and this is not different. Due to serverless architecture, your code, your functions can be triggered by various events. The most recent and most popular are, for example, HTTP triggers when you post get. But you also have timer trigger and so on. So function itself has definition for trigger, for input, for output, like any function. It can be implemented in different languages, in different tools, and easily to deploy on Azure, on your Azure some subscriptions. Okay, we have to just mention a couple things here. If you have a serverless application and there is a big dangers of concurrency execution your code on the server side. Basically, you don't have control on that. Of course, it can be handled by code, but that's something it's cannot be easily fixed. So we need to care about concurrency in this case. As I mentioned before, we need to adjust our architecture to work on trigger-based architecture, which is serverless logic, and but in short, we have other benefits which cover this some kind of downsides. Okay, let's now compare, just to be more clear. Let's just compare Azure Functions and web jobs, because it sounds similar, but it's quite different. Azure Functions can be triggered with any of configured trigger, but it doesn't run continuously. So basically, it's trigger driven action. Web jobs is classical jobs. Actually, it can be triggered, but also can work in continuous web jobs. In terms of programming languages, Azure Functions support some number of languages, but web job supports more or less the same list. Also, about the deployment, it's important to understand that Azure Function is in separated app service that run in app service plan, and web jobs are basically as they are working as background service for the app services. So it's basically different let's say type of execution. Okay, let's compare now. Let's compare now Azure Functions and Logic Apps. Azure Function can be triggered by, like I mentioned, different trigger, but Azure Logic Apps can be triggered via API as connectors. So basically, this is different approach. Workflow in Azure Function can be defined using Azure Durable Function. Workflow on Azure Logic Apps can be defined with Logic App Designer using various APIs as connector. Azure Function about monitoring. Azure Function can be monitored using application insights and Azure Monitor. Azure Logic Apps can be monitored using Log Analytics and Zoom Monitor. So basically, there is difference in the way how we monitor that. However, serverless 360 can monitor both Azure Functions and the Logic Apps. Okay. Okay, it was a bit theory. Let's talk now what we need actually to create Azure Function in C#. Let's go to the practical stuff. Of course, you need Azure subscription. There is trial. It's I think about 1 month, so you can use it for experimenting. However, subscription is not so expensive. So that's the first condition. Second condition, some tool like Visual Studio Code. Of course, we can use any tool, but in this example, we'll use Visual Studio Code because we will run Angular application. So to avoid starting 2 tools, we will use Visual Studio Code for function and for Angular. One note here. Code which is written is C# is .NET Core by default. So when you start a function in C#, it will be .NET Core. If you want some other framework, you need to do some adjustment. And of course, some other languages like F#, like Python, JavaScript, and so on are supported. This function can be started and tested in local. After deployment that function to Azure, it will be available globally, which means we can access to it from any point. Depends, of course, on authorization. Visual Studio can be used as well. That's not important at this point. Okay. Let's say now show what is function, how to start and connect Angular application, and pay attention about cross-origin, which I mentioned later, which is actually the most important thing in this launching. Let's go to the code. Okay. Here I have Visual Studio Code. If you go to the extension tab, we will need to start coding. We will need 2 extensions. First is C# official add-in, which is I have installed, and the second one is Azure Functions official plugin. If we have installed them, that's all we need. If you look to the left, you will see here one Azure icon. If you click it, you will see the whole tree here, actually structure, which is connecting to Azure. I'm already logged in to Azure portal, and this subscription actually is fetched from there. And also, if you look to the function box, you will see there is already some function which are defined. But if you switch to the code, you will see here not definition real code, and you will have access to the code itself. Okay, let's say we want to create a new function. What we need to do? Go to the Azure tab, click new function, and the first thing we need to choose what is trigger. Actually, the most recent and the most used, obviously, is HTTP trigger. We need to define the name and to choose what kind of access rights we want for it. In this case, for this example, it's anonymous because we want to access to the URL without any interruptions. And when we start creating new HTTP function, we will got definition here in the box, something like this. But also the example, the template will be created in code box. By default, for HTTP trigger, you will get something like this. You will get basically get and a method which can be used for get and for the post, and which receives some query parameter, and by default you will use some text. So actually this is good point to start when you start coding. Okay, for this session I just adjust a bit this example and provide a couple of parameters which I named num1, num2, num3, and just to do any operation with them, I do summary of the first two parameters and multiple with parameter number three. So this is just definition, just to move from the basic template, which is already generated. Because this is actually in starting mode, I will stop it now. And let's say, just for example, let's add one more parameter. Just to make difference to see. Okay, and also we will do something with this. For example, we will multiple it as well with the rest of. Okay. Okay, and we will hit F5 now. It will take a couple of seconds. And the beauty of this is actually this part, because you get the URL, local URLs for any of these functions. I was taking this one, for example, so I will copy it basically in okay, just open browser here to show. And here is the access. will add now 4, and I will add some value, any number, for example. Okay, what I did, I running several functions in local environment. I took URL for this particular function. Enter because this is get method. I enter some parameters and pass it to the function, and you'll see we have a result here. So basically, we hit this function and calculated this result. So basically this works. But now we are still in local environment. For example, you are developing the application and writing function, and everything is okay. And now you want to deploy this to the portal. Okay, I will show now how. But before I deploy, let's jump to the Azure portal just to show where our function should be arrived. We have this part of Azure services is called functions app. I already have one for the demo created function app. It's Global Summit. If I choose it, you will see some panel and a lot of data about this function. However, if you go to the functions tab, you will see the functions which is already deployed. If you look to the Visual Studio Code, it's actually better. It's better here. You will see that's the same function. Now we made some change in local environment, and we want to deploy it. To do this, just click this deploy button here and choose what function app you want, because obviously you can have multiple functions up there. Okay, we'll say deploy, and it's being deployed. Let's wait a couple of seconds. It's a bit slow, but will be finished shortly. Okay, it's completed. Now our changes should be deployed here in this HTTP example calculate functions. Okay, how we can test it? Let's take this URL, but now it's global URL, and move to the browser and put some values in URL. And if I type it here correctly, it should work now. Yes, it's good. Now we have a result here, which means because I provide the parameter number 4, obviously this change has been deployed to the Azure, and we hit it by this get request. So basically, see what we did until now. We open some existing function, modify it, deploy it to the Azure function box, and we tested access to the function from local environment and from local browser, but hitting Azure URL. Okay, that's, let's say, in some way it's server side of this story. Let's move now to Angular. I have here the small Angular application. It's very simple. It's just only one component, and I created just to actually modified some user interface here. And the first thing what we need to do in this case is just to create Angular service, and where we will define functions and calls to the Azure service. If you see, I am already hard-coded here Global Summit Azure Websites API because I need it for it. It's the same URL we use it for here. We can put here a local URL, and the whole time we can develop application in local environment completely. And now I provide parameters, and I call it from user interface by adding some values. Let's because I added parameter number 4. Let's add some number. And before that, let's modify it here. Let's modify here number of parameters. Okay, I set 2 commas here. Now it's compiled successfully. Okay, let's kill this terminal and start it again and run it. This time, Angular application. We kill terminal. It will take a couple of seconds to compile it from the scratch. Okay, it's compiled successfully, and also we got this local URL, local port, which is actually default Angular port. And let's open it, and you will see now we are now in browser in Angular application, and calculated sum is calculated actually. So basically, what we do here, we create a function in service connect to the component, and we hit the URL and the Azure functions in Azure Cloud. So this can be used for okay, this is very simple example, but it can be used for developing much more complex stuff. But this is basically template how we can create application, and any JavaScript application, any front-end application. I took here Angular for example, but we can put anything here, anything work, and create pure front-end application with connection to the Azure function, provide parameters, provide inputs, and get some outputs on our site. This will work in let's say any consequences, but as I mentioned, you need to care about architecture. You need to be care about concurrency programming. You need let's say make this part of application, let's say, smart in order to consume Azure function in proper way. Also, just back to the portal. If you go back to the function app, as I mentioned, we have full control here, so we need to manage these functions in a lot of way. We have a lot of metrics here. We can use this for debugging. We can basically export this data. So with parallel developing in local and Azure portal, you can build, let's say, pure serverless application. And just to conclude, at the end, I think Azure functions are really good things, especially for smaller application, for enterprise application, and some bigger application. Of course, you will need to care about a lot of things, but for smaller application, which have basic functions and basic functionalities, you can very fast build your front-end application and connect them for Azure and move this logic in some C# code, which will be deployed to the Azure and have full control here. Via this function. So basically, this is something I want to show today, just to make people more familiar with what is serverless, what is Azure function, and for what this can be used. And I hope this was useful for audience. Okay, that's basically what I want to present today. I don't know, maybe we have some questions in this point.
All right, Igor, that was absolutely great. A lot of code going on, I would say. Right, you first covered the concept, right? Then you moved to the demo, and you're saying that, hey, this is how it works. So that was absolutely great.
Yeah, I just wanted to avoid mixing slides and code. I think this is better. Just few words, not so much theory, because it's boring. Theory is boring. So just to show example how to, and if someone want, it will explore further and so on.
Yeah, I loved it, right? When you covered the first theory and then quickly moved to the demo part, and it covered the entire what you had in the slides. I think we're running a little fast today. Any final thing you want to plug in before we move to the next session?
No, I just want to highlight that everyone should try these Azure functions, just to use it in smaller example projects, just to get sense how this works, and that's something which will be much more used in the future. That's my feeling, and just want to highlight that point. That's all.
All right, great. Thank you so much, Igor. I really appreciate you accepting the invitation, and it was absolutely amazing session. We would love to have you back when you were available. Until then, take good care of yourself, and yeah, have a nice evening at your place.
Thank you, Simon. Have a nice.
Thank you.
Cheers. Bye.
Bye. All right, with that session, we have we'll take about a 25 minutes break, but in that break, we're gonna give you a session by Sammy. Sammy had a session in the morning that was about how you can do the bot development from an idea to the deployment. We're gonna play that video, but we'll be back live in about 25 minutes with Shell's session on Innovate Faster. So once again, it's Sammy joining us with his session on from bot idea to production, if I'm not wrong.
For joining me at the Cloud Summits today. Looking forward today to talk about a bot from ID to production. So today we'll be discussing 3 different topics. How are we getting to the ID of what kind of bot do we want to build? What infrastructure do we need, and how can we convert it into code? And then, of course, the most important part, the logic of your chatbot. And then at the end, how can we build the full CI/CD flow on that? My name is Sammy. I'm a CTO at Arinti, which is a Microsoft partner here in Belgium. and I'm a Microsoft AI MVP for already 2 years, and I'm also part of the global AI community as a board member. So let's kick off this session with the first topic of the day, and that is DID. So with my own firm, what we do is always start with a workshop at our customer. Why? Because our customers might have specific ideas about what they want to do with a chatbot, but for us, it's very important to make, first of all, a bunch of things clear to them. Many do not fully understand exactly what a chatbot actually does, how it works in the back, and we find it very important that they understand that, because it gives them a better idea of what is possible and what is not possible. In the meanwhile, we explain them all the things that can go bad and the pitfalls of projects that have happened over the last 5 years that we've been doing. We need to explain them that chatbots are mostly built to lessen the work done by your customer care center so that they can focus on the most important part of their job, or focus on more important parts or more difficult problems that are there in the company. We will ask them questions like, what questions do you get the most, and what actions do you need to take more often? And then also take in mind that they don't start building a process for something that happens only once in a while, because it will take a lot of time to build with a short return on invest. It's very important to set expectations. A chatbot is a piece of software and it needs to keep on living. It's a never-ending product because you always need to make it better. So it's very important to work on an idea that is in an agile way. A chatbot needs regular deliveries of small extra features. And then very important, and that's something that you need to make clear from the beginning of your chatbot, is make sure your customers know exactly what you need to expect. What does that mean? Well, in the first messages, already tell them, like, this is what I can do and this is what I can help you with. Now, after you've set up your ideas concerning what you want to do, now the next steps will be, how do you want to interact with your customers? Do you want to be extra polite to them and always talk to, hey sir, here, hi madam, or you just, hey you, how are you doing, being very casual? It's something you put in before you even start building your chatbots. We work together with the UX experts to be able to even draw out specific dialogues already. So it's been configured and drawn out what it will look like. And from there onwards, we can start developing the chatbots. So with other words, everything has been drawn out and written out what exactly the chatbot will do or say. And from there onwards, we can start developing and training our chatbot. So now we have our full idea what we want to build. We know what the scope are. The scope is perfectly defined. Now we'll need to go into the next step. We know as an architect, solution architect, you know what services you will need on the Azure platform. Now let's start on building that. And that brings us to the second part of the session. Very important part, and that's infrastructure. Now we hear more and more about infrastructure as code. Now I'm a big fan of bicep code, and before we had ARM, which was okay to build infrastructure as code, but it was not always very readable. Of course, we also have Terraform, which is cloud independent, but since I'm mostly putting my focus on the Microsoft platform, well, I'm very happy with the code that the new environment that Microsoft created, which was called Bicep. So infrastructure as code, very handy, especially if you have an environment, for example, that gets, you have a lot of issues, then it's easily to spin up a new environment because everything is already in code. Same for all your apps and so on. In DevOps, we can fully have release cycles and manage it so that works perfectly. Now, for our bot infrastructure, we need to have a specific architecture, of course. This is a simple infrastructure design that I drew. The bicep code, we will discuss that in a bit, is also available on my GitHub, github.com/Sammy Deprez/bicep templates, and there you will find bots also. So what's the code behind a chatbot? Well, it all starts with the logic of the chatbot, and that's all saved within this web app, which is of course running on app service plan. From there onwards, well, we'll need to do communication with, for example, Lewis to be able to understand what the human is saying, what the humans are saying. So data will be sent up and down to cognitive services language understanding. Now, from there onwards, we of course need to be able to save what has been saying. Since the chatbot is stateless, well, we still need to somehow keep track and being able to return, for example, what the variables were that were saved. So that will be all saved in our Cosmos database, which will be purely used for conversation state storage. Now, of course, within chatbots, we also have Q&A maker to make a knowledge base which can easily be queried by questions and answers. Well, for that, we need another web app, which is the Q&A API, linked to the cognitive service Q&A maker and the Azure Cognitive Search, where actually the Q&A knowledge bases are saved in. Now, this is all on the back end. Now we also have our front end of the bot, which is this part, the right side here, and that first part is the bot channel registration. The bot channel registration is the front entrance to your bot. So it will make sure that there's communication from a web chat, from Facebook, from WeChat, and many Skype, Teams, or whatever channel that you're using. It all starts here. So there's a secure communication line between these two elements, between the web app and the bot channel. The bot channel registration can also be defined to be able to handle speech, and that's also being able to be configured in there. So therefore, we also put the line here to cognitive services to the speech service. Here on the top, we also see an Azure function, and that I always use for my authentication method for web chat. So that way we don't need to put a direct line secret into our web page where the chatbot is running in. It means we will do a call to the Azure function first to return the token, and then communication can happen between the web chat, which will communicate through the bot channel registration to the web app. And then of course, to finish it up, we have our key vault to just keep track of all the secure passwords or keys that are needed. For example, our direct line secret or app ID or app secret that is needed also for the communication between these two. So let's have a quick look between on the bicep code, how that looks like. All right. So if you go to my GitHub repository, you will notice this. Be better. Cool. So you will notice this element here, and I need to move my face to another place so you can see it better. The code. It always starts from a main.bicep. If you go to the main page of the bicep template, you will also find the way how to deploy the code. So you have this can be done through the CLI on your own local computer before you even push it into DevOps. Now let's go back. So you see here that I call main.bicep. If we go to main.bicep, the nice thing about Bicep is that you can work with modules. So I've already written a bunch of smaller modules to automate certain things. So first of all, I set some parameters that I can also give in from my own environment if I don't give them in. So with the CLI, if I don't give the location, I can still override the location, environment, project name, admin user ID, and so on. Now with the admin user ID, it's the user ID that I'm defining. That's mostly the object ID of my personal account on Azure, so I have access to my key vault. Then I have my application ID and application secret. That's what I need to define, well, to actually create in my Azure Active Directory as an app registration. This app registration will be used for the communication between your bot channel registration and your bot logic. From there onwards, we have a bunch of services that we need. As you might notice, I prefer to use decent naming conventions, so I took over the Azure naming conventions, and each time we add the project name and the environment to the names. So we have a key vault, the app service plan, we have the app service where the bot is running on, the function to get the direct line token. We add some application insights for logging. We have a Cosmos DB. Then we have Lewis authoring and Lewis predicting. We have our bot service, which is the channel registration. We add the logic also in case we would like to use it, and later on the name of our Q&A and the name of our bot. This is the bot that will also, the bot name that actually we're going to be used in the environments too. So what I added here is a little script, which this is still not correct yet. This bot name should still be a variable that I can also give into the CLI script. So then we have a bot endpoint. This is based on the app service name that we created our app on. I try to tag my services with a small description, what it's about and in what environment it is doing. And from there onwards, we're going to call multiple modules. And so the first one here is the module key vault. Then the next one is a module I wrote, key vault secret. Let me open it to actually add a secret into the key vault. So notice here, I make the key vault. So I have my module KV. And from there onwards, I can use KV outputs.name. And so I use the key vault name to add the secret, which is called bot app ID, with the secret value application ID. And this application ID is what I defined here. So let me go back to the modules. And there you see the resource that we're calling, the key vault name, the secret value. And what I'm returning is just the secret name, just to be able to add something. Now let's go back to our main. So from there onwards, I also add my bot app secrets. I create the server form, which is actually our app service plan. Then I create the website, which is then again is the app where the bot is going to run, the logic of it. And notice here again, we have ASP, and I'm using here ASP outputs.id. So I'm giving the ID of this created server form to how to create the web app. From here onwards, I adding security. Well, I'm giving my web app permission to read my key vault. So here I use the app outputs.identity. So in this module, I'm creating also system identity for my web app, and I can go on. Then I create, do the same thing for my functions. I create my function here. I create a Cosmos DB. In the key vault, I add my Cosmos primary key. I create my application insights. Then I create my Lewis. Then my bot service, where I'm going to configure it with my application ID, the bot endpoint. So this is the messaging endpoint that we defined here on the top of the script. So we see here, this is our bot endpoint. Let's go back. We give some details about the application insights. And then once that is created, we get returned the bot direct line secret, which we're also saving into our key vault. Then after that, we configure our app settings with a bunch of stuff like our Microsoft App ID, app passwords. So this is needed to be able to communicate, to have a communication between the bot registration channel and the bot logic. So these details are needed in your app settings. I do the same things for our function where I define the direct line secret, where I do not enter the value just like that, but I define it by telling it where in the key vault it is saved. That's also why, as well as the web app, as the Azure function needs permission to read the key vault. Again, that's a secure way, and you don't need to save any passwords in your code. And then we create our Q&A. Again, we say on which server farm it needs to run, so which web app. So we don't need multiple web apps. If you create Q&A Maker manually in the Azure services, it will create a separate web app, which also means it will duplicate your cost for running your bot, because you need 2 app service plans then. By doing it manually, you can define beforehand already, this is the app service plan that I want to use. And that's it. And then we have a whole setup, and if you execute that, it nicely generates all the resources that you need. Now these scripts that I will open here again, this AZ deployment group create, this will create a resource group on your subscription, and at the end will create all the resources that are needed. It's also possible to create it on, you define already so in this case we defined already what the resource group is going to be, which can also create these scripts on a subscription level. And then you can run and create the resource groups manually in case you want to make, for example, a resource group specifically for networking. In this case, we didn't configure any VNet configuration, but it is possible. It would be nice if those resources maybe are in a different resource group, so you can keep networking and application separately. But that depends all on what your governance is on Azure and how you want to handle it. So let's go back now. We've seen all the parts now for Bicep, what is needed. Next step is now the code. So let's have a look on that. So that brings us to the last phase of the project, and that's of course, the biggest part of the project, that's building the code for your chatbot. So that brings us immediately to Bot Framework Composer, which I'm not gonna open up and show you around in it because that's not the purpose of this project, of this session, but we'll go straight into DevOps. So let's go here to my DevOps environment. All right. So what you see here is a project called Chatbot Robin, and on the left side, we click here on repos and then files. Now what you see here is the first part is here, which is called Robin, and Robin is actually the folder which is generated by Bot Framework Composer with all the details inside. I did not change anything to that, and I just add changes of my bot purely in there. Another part I have is my build template, and this is all defined by extra code that is actually from a part of the Microsoft Docs. So there's a specific article about setup continuous integration and continuous delivery for a Composer bot. It's still in preview, and it's something we are personally working on as a company also to still improve, because we still see some missing items, and we'll go over that in a second. So they explain it quite easily, all the steps that you need to take. It's all based on one YAML script that you need to take into your pipeline, and it will call different ones. So let's have a quick look on that. If we open our YAML script, to the first one, build and deploy. All right, so we set up a couple of keys variables that we're defining, And from there onwards, we will do install prerequisites, build and deploy models, and build and deploy .NET Web App. So let's have a quick look in each of them. So we'll start at the prereqs. So in the prereqs, we're just installing nodes using the bot framework CLI, so we can actually trigger, for example, a training script of Lewis or a Q&A maker, and then we just configure what .NET Core version we want to use. Let's go to deploy the models. So again, we set some parameters, we configure our working folders, but then here most importantly, training or language understanding models. As here you already see we use the PF CLI, so the bot framework CLI, to use the generated language understanding files that were generated by bot framework composer and to ship it to Lewis to train it, all the different ones. And then in our next step, we're actually going to publish Lewis via a PowerShell script. Second part, after Lewis, we want to publish our Q&A, send all the knowledge base information, and then the third part is generating an orchestrator model, which is very important to have a good combination between your Lewis and your Q&A models. After that, we're just generating an archive, and we publish that archive to our generated.zip file. So with this, our Lewis model is trained, our Q&A model is trained. Now the last part is training, well, not training, is publishing the bot on itself. So if you go back, we have build and deploy .NET Web Apps. And if you go down, we do a build the bot, we publish the build artifacts, and here we deploy the Azure Web App, and we configure it with some parameters. In this case, the Microsoft App ID, app passwords, Lewis endpoint, Lewis authoring endpoint, the region, the environment, the default language, and so on, Lewis name, and the different app IDs that needed for this. So there's a bunch of parameters that needs to be configured. Now, once this is all done, normally you don't need to touch these YAML scripts, and is it only the first one, the build and deploy script. Now, once that you have that, if you go to pipelines, you can say I want to create a new pipeline from an existing YAML script, and then you can just, then you'll have something like this. So it will create a pipeline, and each time, depending on, let's open here our YAML script again. We see here trigger now as production, but you could have different ones between your environments. So in this case, we have a dev environment which has a separate build and deploy YAML branch from. Okay, so it can be different depending on the different repositories that you have. And that's one thing I wanted to share concerning what we have here. So we have the Microsoft provided these scripts to be able to automatically do deployment of your bot, which is perfectly working if you have one environment. Now with a CI/CD environment, you might have a dev and acceptance and a production environment, depending on your use case. Personally, I think it's always good to have at least a separator between dev and production, so you can also play around with new things and you don't crash your production, so it's more stable. Now, because of working with pipelines here, we do not really have releases. So this is something I'm still working on. It's something that I will be sharing with the community soon, once it's up and running. So then the idea would be that you have a pipeline that does all the checks and will do the builds and see if everything is in order. And then you will have a release pipeline where you can say now it automatically goes to dev, and when you say okay, it's ready to go to production, you can just push it to there. So I hope this gives you a bit of an overview of what is actually possible with Bot Framework Composer, bringing it first, getting your idea of what you want to build, getting your infrastructure as code, which was already shared in my slides, that you can perfectly reuse. And then, of course, once your bot is there, to set up the full pipeline from dev to production. As I said, it's still a work in progress also on my side to finish that up and make it available for the community. So keep on following me on Twitter. It's @Sammy Deprez, or just like my GitHub page, and you for sure get an update once it's there. So thanks for joining this session. I hope you enjoyed it, and enjoy the rest of your day with more awesome sessions coming up.
All right, with that session of Sammy on how you can go ahead and build a bot from idea to the production, we now move to a next session that's by Shell, that's on Innovate Faster. Now, if you don't know who Shell is, Shell is someone who always comes with some new ideas, and his sessions are always very interesting. And for today's session, he's going to talk about Innovate Faster and cloud. Shell is the head of digital transformation and co-founder of ING Direct. So without any further ado, let's have our next speaker of the day, Shell at Cloud Summit 2021.
Did you know that when it comes to innovation, speed is an extremely important factor? If you ask Elon Musk or Snoop Dogg, they may refer to a certain type of speed. What I'm referring to is how fast you can deliver innovation. So when I started to work on this presentation, I was asking myself, is there a better or faster way to do presentations? As a matter of fact, there is. Hello, I'm Shell's digital twin, and I'm fairly sure you were not aware of this fact. Now, let me pass the mic over to the real Shell.
Hey guys, I am happy to be here, and I don't know what you think about my digital twin, but that was actually using a cloud service to create an avatar. So hopefully you enjoyed that. What I'm going to talk to you about today is, can you innovate faster in the cloud? And the answer is yes. And I'm going to walk through a process and a methodology to explain how that's possible. So I've broken this up into 3 parts. One is you have to have the right environment. So I'm going to talk to you about a proper digital transformation framework. And then we're going to break it down further into a digital factory, what that means. And then I'm going to give you some examples around cloud innovation. So first, you have to be in the right environment. And again, what I mean by that is to have the right framework. So I've broken this down. This framework has developed over the years as being an executive founding member of ING Direct and a senior manager at Capital One. And then the last few years helped consult and implement transformation for Fortune 500 clients. We feel like, we have a pretty good hold and grasp on what is needed. So I'm going to quickly go through these pillars and building blocks. So you need a strategy. The mistake a lot of companies make is they create a strategy and then they leave it. Even the strategy needs to be flexible. In other words, a market condition may show up, i.e. the pandemic, and now you have to switch. And then you need a board of directors that can support this, the strategy, by funding it. And also you need to implement proper governance of the strategy. And the idea is that you want a shared vision for your company. So again, this framework will work for both large, medium, and small companies, in my opinion. The next pillar on the left side is human capital a critical element. And the idea here is, do you have a digital workforce? Does everyone understand technology? Do they have digital DNA? Can they work remotely? How do you train them on Agile? Do they understand Agile? And how do you scale that internally? And the outcome that you want here is high velocity teams. Then last one, you need modern tools, right? So this may appeal more to the audience here today, but you need the Atlassian type toolkit, right? You need DevOps, you need security, whether that's cybersecurity, SecOps, and what have you, right? So you need a modern tool stack. And then you don't necessarily need more data. What you want is actionable insight, right? And that comes from having a proper data lake, perhaps, and then data scientists, ML capable resources, and that hopefully will lead to artificial intelligence. And then this is not a comprehensive list of technologies. It's just an example. You could add quantum computing, LiDAR, whatever you want in this pillar. The idea is someone needs to look at what's on the radar screen in terms of technology. Is this something that can apply to me if I'm in banking? Should I be, looking at voice? Should I be looking at computer visioning? And then the top pillar is all about the product. At the end of the day, you have to ship, right? So how do you do that? How do you innovate, build better products? And that's why I want to spend 5 minutes on what I think is a critical building block, and that's having a digital factory. And then once you have all those ideas and concepts and MVPs and 1.0s, they need to move to your enterprise product portfolio. If you're a smaller company, you may have one product or service, and that's the end of that for now. But the point is, you need to ship. And it's not all about AI and robotics here today, right? This is a big number, and this number is what McKinsey reported as 54% of the reasons that transformations fail are due to human capital. Okay, that's not blaming human capital. Either they are not trained, they don't have the tools, they may not understand Agile, it may be poor leadership, but that's a big number. So it's almost like you can spend a lot of money on technology and AI and data and cloud, but at the end of the day, there is a big human element. Okay. With that, hopefully that gives you a flair for the right environment. And by the way, that environment is what the FANGs are using. The Facebooks, Amazon, Apple, they are executing flawlessly on all those building blocks. But let's talk quickly about the digital factory. And just to keep the navigation here so you can follow me on this map, this is what I'm talking about. So this is where we are on the map, digital factory. And that's what the model is that I'm going to share with you right now. So what is a digital factory? It is a way of moving ideas and concepts from use case, right, to workshop, right, to prototype, to proof of technology, to proof of concept, to MVP, to 1.0, and then operationalizing it. So these are the typical stage gates. And the idea here is to set up a process that you can rinse and repeat frequently at rapid pace. For example, one of these factories that I stood up recently, they've run 24 use cases through the factory in 14 months. So call it 20 in 1 year, all right? And that is pretty good pace. And so it's not about just one process, it's about scaling this and having a team that can take any idea or use case through this factory model, if you will. And the use cases should come from the business. It may come from the associates. It may be your suggestion box. But typically you have the business that should be driving this. Otherwise, you can just be working on cool technology and not add value. So, and it's not just me saying it. This is actually from McKinsey from last year, where they said that the digital factories is a good approach to showcase and scale your transformation journey. In addition to the factory, you need an ecosystem, and this relates a lot to innovation. If you rely on just build it internally, you're not going to go anywhere quickly. You have to have an ecosystem. Let's say that you're a bank and you want to onboard a customer faster, because right now it takes 45 days to pre-approve a mortgage. Okay, it's too long. Okay, typically the bank would say, okay, let's put 5 people on this and see if we can get it down to 30 days. Well, why would you not search the marketplace, scan the startup community, maybe via an accelerator or even universities, and find out if someone has built a proof of technology or concept where they can onboard someone in 24 hours, right? And then you contact that entity and try to leverage that technology, use it, borrow it, license it, and build a rapid proof of concept. So you need a great ecosystem to accelerate your innovation. And just to spend some time on this, a proof of concept does not have to be $1 million, right? A rule of thumb is, at least how we try to coach our clients, is in this rapid entrepreneurial environment that we're trying to instill, 30 days and 30K is kind of a rule of thumb. All right. So if it takes 90 days, then it turns into a project, right? I've done POCs that have been $600,000-$700,000 and took 90 days. But those are more exceptions. I've done one that was $100 and took 24 hours. All right. So use this as a rule of thumb. Now, why would the cloud be an environment where you can innovate faster, and how would that work? Well, if we take what is, call it on-prem on the left side and cloud on the bottom, those two streams. So say you're on-prem, then you would typically follow the process I outlined, where you have a use case, you move to proof of technology, you get feedback, you have a proof of concept, you pilot that, test it, and move it forward in your, call it factory stage gates, okay? That, again, getting to POC should take 30 days. Getting to MVP may take 4 or 5 months, right? But getting through a POC should be 30 days plus minus. So we're talking weeks and months for that. If we contradict that with a cloud environment, then imagine again that you're the bank and your mortgage department, right, says, hey, we have all this data. Can we run a machine learning algorithm, and then can we add seasonality to it? Can we add data points to this model and run that training model? And the answer is, yeah, you can do it at rapid pace right now if you're set up properly in your cloud. If you're not set up properly, that's not going to work, right? So that's back to the transformation framework, where is everything synchronized, right? Because they are individual blocks, but they have to work in symphony. So the answer is yes, you should be able to innovate faster in the cloud, set up in the right environment. And let's just take an example and see what Azure offers us, right, in terms of innovating faster. All right. So this is directly lifted from the Azure website. So if you look on the left side, you have all the activities, right, that you need to do on the left side in terms of machine learning. You can add data sets, right, build and train your model, right, rerun it, hypothesize with your team over it, rerun, add data sets, iterate, improve, and then you go ahead and deploy and manage it in a pilot. All right. So look at this. How simple can it be? The whole menu is there for you. The process is set up. Okay. And I understand you may say, well, we need security access from IT to get new data sets, from the savings account customers, because we want to cross-sell our mortgage product to them. Well, that is an internal process issue, right? And not a data, not a machine learning capability issue. The next step would be for your organization, a bank, to move to the cloud, maybe have a data lake where access to data sets is quote unquote as easy as one request and it's done. And I know that sounds easy, but we have clients where that is happening. And then I do want to bring up the fact that you may hear about DevOps Factory, AI Factory, and you just heard about Digital Factory. And yes, they are indeed different. So if you can take the framework and the process of the Digital Factory I just walked through, and then overlay that in an AI factory, that's what an AI factory means. It means adding data sets quickly to the machine learning algorithm, right? Testing it, having a team verify the hypothesis, and then add human capabilities to the modeling. Does it work? Can we test it? If you're Capital One in the banking instance, maybe you test this in one of their cafes, right? Or maybe you just run a training model and you have data scientists looking at it, verifying this with the business owners. Then the last few minutes, I do want to talk about some examples, right? So one example I always like to use when it comes to AI is this. If the Air Force is able to fly a B-52 bomber with AI, right, we should be able to implement a simple machine learning algorithm. And the military has been using drones, right? But that's using a human operator, right? I'm talking about 100% liftoff, flight, and landing using AI, all right? So don't sweat your machine learning algorithm, right? It should be easy. While we are talking planes, I'd like to play this quick video. It's a partnership between Rolls-Royce and Microsoft, but it demonstrates exactly what we've been talking about. So take a listen.
As an airline pilot, I know that to fly with the best, you need to work with the best. With over 13,000 engines in operation around the globe, Rolls-Royce provides the services to maintain them at peak performance. Today, each engine has thousands of sensors that can produce terabytes of data on long-haul flights. Making sense of all that data is critical in transporting my passengers safely and efficiently. Rolls-Royce uses Azure IoT Suite to analyze data remotely and deliver real-time actionable insights to me and to the airlines about engine performance and operational efficiencies. Advanced analytics help us optimize fuel economy, anticipate maintenance needs, and avoid costly downtime and delays. A single unscheduled disruption and its knock-on effect to a fleet and the passengers can cost an airline up to $1 million a day. With early notice, our team can proactively have parts at the right place and time, reducing inventory costs and maximizing availability. Up to 1/3 of a plane's weight is fuel. As a pilot, I decide how much fuel my plane carries. Insights into engine efficiency, weather conditions, flight path, and scheduled landings impact my decision. Cortana Intelligence helps me choose the optimal fuel level to maximize efficiency. With 40% of our operating budget devoted to fuel, even a small percentage reduction can save us tens of millions of dollars each year. Microsoft and Rolls-Royce, reaching new heights in customer value.
So I hope you enjoyed that. So how about another example? Welcome to Philly. If you ever go to Philly, you have to have a Geno's cheesesteak. So let's use this as another potential candidate for machine learning and what that would look like. So let's just say that the data sets here for Geno's would be dollars in sales, number of customers, dollars spent on bread, dollars spent on cheese, on beef. So if we were to run a machine learning model, maybe it would be as simple as what ingredients do we need on a Saturday? Okay. Then you run that machine learning model. That's a simple approach. If you want to go to more of a narrow AI model, then you may say, okay, on a Saturday night, right, before a Eagles game, we sell 25% more cheese sandwiches than normal. Can we verify that? Okay. And then you start adding and combining multiple data sets into your machine learning model, and boom, maybe you can run predictive analytics. So in this case, what happens when Las Vegas bookmakers have Eagles as -10 on a Sunday 1 p.m. home game? Right? Do we increase baguette sandwich and mozzarella sales by more than 50%? So that's the beauty of anyone, small, medium, large, being able to take advantage of this amazing new technology. And again, it's not just me saying it, right? Per Gartner, not only do you have to move to the cloud, right? But they also claim it's the foundation for business innovation. And it may be a stretch to say that everyone needs to be in the cloud. However, this is a cloud event, right? So for now, let's stay in the cloud space, because there are startups, there are small businesses, there are manufacturing that may not have resources to do all the things we're talking about. But the point is, I agree with this statement. There is no strategy without a cloud strategy. So get to the cloud, migrate to the cloud faster, get the right environment set up. And lastly, I want to talk about what I call combinatorial innovation. And what the heck does that mean? Well, that means you're combining multiple technologies into one innovation. And I love Spot for that reason. Spot has a payload capability of 14 kilos, I don't know, 35 pounds or so. It has a LiDAR built in. It has 360-degree perception for environmental mapping. It does edge computing on its own processor. It has a thermal camera, right? You can add third-party sensors on top of it, right? And it comes with a software development kit, and the APIs can be connected to the cloud. So this is an amazing piece of innovation using combinatorial innovation, in my opinion. And then at the end, listen, guys, there is hope for us, right? I think despite all of these technologies, we are playing a major role as humans. Most of us are in the tech space, but I'm looking at some maybe next generation team structures here and titles. So think about immutable infrastructure, for example. What does that mean? Well, it means what Amazon is delivering. When you order a package and it says 4 p.m., it is usually around 4 p.m. The post office, not so much, right? Netflix, I've had it, I don't know, 14 years. I don't think I had one billing issue. That's pretty solid. I think the next generation of platform team design is going to be around a team around platforms, for example, infrastructure as code. I think we need to move to fusion teams, meaning there's only one focus, and that is the customer outcome driven focus. What is it that our customer desires out of their product or service? How can we set up our team successfully for that? And then Chief AI Officer is happening at a rapid pace. And then voice design. I think voice is going to just be a massive new technology taking over enterprise. So that's it. I'll take some Q&A and I'll leave it at that.
All right, Shell, that was absolutely amazing. A couple of things that I really loved is how you compared if you are on premises, it's going to take you like weeks and months to reach your MVP. Whereas if you're on cloud, it's going to take you only a few hours. And I really could connect when you say that, hey, if it's an Amazon, it's going to tell you that, hey, I'm reaching your place at tomorrow at 10 a.m. in the morning. It's going to be somewhere around that, but definitely not the post office. I definitely connect. I think it's around the globe. It is the same thing. People really like your session. I see people are saying it was a superb session. There's a question by Andrew. I've not read it. How do you keep on top of this? I don't know what that means. Can you make sense out of it?
Yeah, for sure. It's a plethora. It's not just watching TV, right? No, but watching Shark Tank, it does inspire you. Reading magazines from other industries, like I'm in the digital space. However, I read Architecture Digest. I read motorcycle magazines. I'm a gun owner, so I shoot and compete.
Wow.
Okay, well, but then you look at innovation in all those industries. I ride a motorcycle. I look at innovation around electric bikes. Okay, so that leads you to, wireless charging for motorcycle. Is that happening? What are the technologies? So I would say take your hobbies and explore them, and then pick some new industries and just read up on magazines and maybe look at Kickstarter. What's happening on Kickstarter? What product?
That's a good idea.
Right. So
Yeah, people say it's very different presentation. Mahesh is asking, where did you buy your digital twin? He said online.
Well, I mean, if I said I made it, that would be weird. So my mini-me is from a company that actually are just surfacing, and their target market is actually making someone that does a lot of videos. How can you do it faster? How can you literally produce your own videos faster? So in this case, my avatar is using a catalog, synthetic voice. But the next phase for me would be to record my voice, use machine learning to train my voice, and then have my voice come out of my avatar, if you will. So it's pretty weird.
Yeah, so it means I go in and upload a script, right? And that AI would just create an entire video out of it with me and my audio.
For now, I would say for me to create a 2-minute product video for us at Cirrus Labs for cloud migration, then that's probably 3 to 4 weeks, right? 2-3 weeks, come up with a script, produce it. Now it's 15 minutes.
Wow, I gotta try it. We make so many videos. I think we're really lagging behind with the innovation part. Ganesh is asking your thoughts on features with value addition and innovation in cloud technology coming days.
Well, I will have to watch a few sessions if that's the question. I don't know if I get the question. So the question is your thoughts on innovation. Well, again, my thoughts are you need the right environment. and you need to spin up a team. If you're a bigger firm, you need to spin up a team that is focused on taking concepts through a factory, right, rapidly. Whether that's the digital factory, DevOps factory, or AI, each building block that I talked about can be its own factory. That's how the Apples and the Amazons and Netflix are operating, right? Netflix
Microsoft.
uses chaos monkeys, right, to chase down bugs in their system, right? Basically robotic programming. So, but anyway.
Yeah, definitely makes sense. There's someone saying in the comments, innovation not in guns, please. So Shell owns a gun, so maybe he may do some innovation there. All right, Shell, any final thing you want to plug in before we move to the next session?
No, this is awesome. Let's all go and innovate in the cloud, make it happen.
Yeah, thank you so much, Shell. I always enjoy hosting you. As I said in the beginning, you always come with something very new. So we really enjoy hosting you at the Cloud Summit. We'd love to have you back whenever you're available. Until then, take good care of yourself and have a happy Wednesday. Thank you.
Thanks, Simon, and thanks for listening. Bye.
All right, with that absolutely amazing session of Shell, we now move to our next session. That's by one of our partners, that is a page Rundeck by PagerDuty. Joining us now is Jesse, who's going to talk about how you can automate yourself out of job. It's actually safety, delegate the management of your Azure deployment. So we're going to play a quick commercial, not commercial, I should say, a quick 1 minute break, and then you will see a session. Now, here's something to note. This session is already recorded, so we won't be able to take Q&As towards the end. But after this session, everything would be live. So yeah, let's get to the next session at Cloud Summit 2021.
Life in operations. It's a mix of planned and unplanned work. Operators frequently find themselves getting interrupted with an endless stream of tickets, often for doing the same things over and over again, and those tickets are often escalations to yet another team. Resolving these tickets leads ops teams to searching documentation and runbooks, looking for steps to complete routine procedures. Hopefully, the docs are up to date and the operator has access, and they don't make a mistake. And of course, that the business can afford to wait. Wouldn't it be great if there was a better way? What the operators really need is their runbooks to be automated. Here's where Rundeck can help. Rundeck by PagerDuty is a leading solution for runbook automation. Customers use Rundeck to delegate automation to the right people in the organization. Now users get self-service access to operations that previously only subject matter experts could perform. Rundeck automates IT workflows and processes, replacing the previously manual procedures found in documentation. Rundeck doesn't replace existing automation. It makes existing automation, scripts, and commands more secure, auditable, and safe to run. Rundeck is a central hub for automation, connecting key tools and infrastructure in operations workflows. Rundeck helps teams resolve incidents quicker, avoid interruptions, and get more done, all while ensuring things are locked down and remain compliant. First responders are empowered to resolve incidents themselves instead of escalating, minimizing disruptions and reducing outage time. Operators become more productive. Developers stay focused. IT users can solve problems for themselves with the click of a button. Rundeck customers regularly see 60% shorter incidents, escalations cut in half, and 15 to 20% increase in productivity. Sign up for a demo today.
Today we're going to be talking about how to automate yourself out of job and how to safely delegate the management of your Azure deployment. My name is Jesse Holdsworth. I'm a senior solutions consultant here at PagerDuty, focusing on Rundeck. You can find me on Twitter at jholds. And I'll also be joined today by my teammate, Jake Cohen, who's also a senior solutions consultant here at PagerDuty. So a quick agenda for today. First, we'll talk about the status quo that we see for operations, and we'll make the case for making operations self-service. We'll then look at some ways to create runbooks that leverage existing scripts and tools that you've already made investments in, as well as some strategies for getting started. And then finally, my colleague Jake is going to round things out here with a demo of Rundeck in action. So I have a feeling that just about everybody tuning in today is familiar with some of the benefits of moving workloads to the cloud. We now have the ability to scale resources like never before, which has unleashed innovation that has disrupted many industries, from taxis to entertainment to financial services. And the cloud is incredibly accessible with very few barriers to entry. So rather than having to go through long procurement cycles to purchase and set up your hardware on-prem, just about anybody with a credit card and an internet connection can get started building on the cloud in minutes rather than months. And so this combination of accessibility and scalability also enables much greater agility to businesses, which allows them to quickly adapt their products to customer demands. And so this newfound agility makes the cloud a strategic topic for most executive teams, even companies that wouldn't normally consider themselves technology or software companies. And as we look ahead, the future of the cloud is only expected to continue to grow. Things are not slowing down here. Gartner predicts that in 2021, there will be 18.4% growth in cloud services to total $305 billion. And this is driven in part by the COVID-19 pandemic. And this has really validated the cloud's ability to help businesses adapt to new challenges and in resource constraints here. While the promise of the cloud is inspiring, we also need a healthy dose of reality to keep things balanced. So while there is a ton of potential value to be unlocked by removing the constraints of traditional IT, there are also new operational challenges that often arise as companies migrate to the cloud. So for example, rather than having everything you need to run on your for your application installed on your local machine using the WAMP stack, we can take advantage of cloud resources such as Azure SQL and blob storage. And while the scalability of these services is certainly a benefit, there are also some more disparate services that need to be connected together. Or we could take an example of breaking a monolithic application into microservices. At first glance, it makes sense, right? Developers are better able to work on different areas of the application without interfering with one another. And we can more efficiently scale the parts of the application that are seeing the most demand. But at the same time, we now have a much more complex system to maintain and operate. And so this image up above here shows a typical microservices-based application for mid-size SaaS service. Each one of these connecting lines in the middle is now a point of failure that we need to account and plan for here. We touched on the topic of accessibility earlier, and it has proven to be a double-edged sword. So while cloud platforms like Azure have made it very quick and easy to provision and manage compute resources, this can also be seen as a security risk, as we obviously don't want people taking down our production environments on a whim. So many business users are often prevented from accessing the Azure console. So this brings us right back to some of the typical challenges that we see with on-prem systems. For example, there are many times when a business user needs some new resources created, such as they're bringing a new customer online. But since that business user doesn't have access to the Azure console, that means they need to file a ticket or request somebody else to handle this. And this, this sounds familiar, right? The way we usually see this sort of scenario play out is we have a business user over here on the left that needs something done in the Azure console. Maybe they need a port opened on a firewall to enable a new integration. Maybe they need a new VM created, et cetera, et cetera. But they either don't have the knowledge or the permissions required. So they have to file a ticket that gets routed to some sort of a cloud or an ops team. And somebody from that team is going to go ahead and make the requested change. This sort of setup usually creates a bottleneck that slows down the business, since these tickets for repetitive tasks are being manually executed by subject matter experts. And this also means that as more tickets come in, we'll need to hire and train more and more people to take action, which makes it challenging to scale this area of the business. And last but not least is the effect that this constant interruption has on the focus of our subject matter experts taking action on these tickets. So while one such request might not seem like a big deal on its own, the volume of these requests like this often becomes a major barrier that keeps organizations from maximizing their investment in the cloud. As requests like this pile up, attention of the ops team becomes focused on these repetitive low-value tasks rather than working on our products and services better for our customers. So we recognize that the current pattern that we see all too often is inefficient and challenging to scale. So what's the answer? How can we reduce the burden on operations and cloud teams and empower both developers and business users with quick access to the tools that they need? The answer, let's make cloud operations available at the click of a button. Instead of waiting for somebody else to execute a script or a manual workflow to fulfill your request, why not automate these processes and wrap an easy button around them so that users can just push it when needed? By enabling a self-service model, we can give people the ability to execute predefined workflows that may involve both cloud and on-prem systems. And this eliminates the need for users to be trained on these specific underlying systems. And it also alleviates access challenges since we no longer need to log into these systems to get things done. There are a number of reasons why companies are enabling self-service for their users. One is to reduce toil across teams. So rather than spending time on low-value repetitive tasks, our users can execute the workflows that they need right away. And this helps them improve productivity and business agility since they're not waiting around for somebody else. Reducing organizational silos is another benefit we often see. Many organizations have complex workflows that involve different systems managed by different teams. Let's think about a typical workflow for deploying an application. Processes like this often involve different teams. A sysadmin might need to make some changes on an application server. A DBA might need to update the database schema. And maybe a network engineer has to make changes to the load balancer or to a firewall. If we can automate these tasks from different teams and connect them together in a single workflow, we'll be able to deploy both faster and more reliably. And this all helps us save time and money, especially when we think about resolving outages or incidents that are impacting our customers. Having the ability to get things done quickly is key to keeping customers happy and minimizing downtime. And finally, self-service operations also allows us to leverage the current tooling we already have in place. Self-service makes these existing tools and processes available to everyone who needs them without requiring them to be an expert. When people start thinking about self-service, the question often arises, so does this mean I need to automate everything I'm doing today? And the short answer to this is no. We want to focus on the low-hanging fruit that's going to make the most impact. I usually recommend focusing on workflows that are both time-consuming, repetitive, and have an impact on the business. So for example, if I'm a developer and I need a new test environment, let's say my company requires me to file a ticket to get one created, but that ticket won't get worked on until tomorrow because the team it's assigned to, they're on the other side of the world and they're at home asleep right now. I'm going to lose productivity for that day while I wait. And if this is a common occurrence that happens hundreds of times a year, this becomes a really good candidate for automation. Another category of use cases we see very frequently involves incident response. So let's say we have an outage in an application that is impacting one of our customers. If engineers need to manually collect diagnostics and perform remediation, this is time spent that's often has a direct correlation on lost revenue. So providing our on-call engineers with automated workflows to collect diagnostics and better perform remediation can have a major impact on our ability to get things back up and running quickly. These are also really good candidates for automation. From a security perspective, we also need to understand how automation solutions manage access to the platform. Since giving everybody the ability to do anything on all of our systems is not usually a recommended approach. So leveraging tool sets with role-based access controls is a good way to make sure you're giving people the right level of access to the automated workflows based on their job. In fact, leveraging automation can actually improve your security posture if implemented correctly. since it helps avoid the need to give out credentials to your systems. So for example, instead of giving a developer SSH access to a production server so that they can collect logs to troubleshoot an incident they're working on, you can create an automated workflow that they can execute that collects the logs and copies them to a shared location. So this way, the developer is still able to get the information they need to do their job. They don't have access to the underlying production system. And finally, many organizations have lots of existing or legacy tooling that has already been implemented. A major factor in getting started in self-service automation is making sure that your existing tools and technologies are compatible with the solution that you're evaluating. There are many automation tools out there, and most are somewhat narrowly focused on specific use cases or technologies. So it's important to understand what you're trying to automate and what tools are going to be involved in your workflows so that you can make the right decision. When we talk about automation, there's a maturity curve. Here's an operational maturity model we have developed based on the levels of operational maturity we see from customers. Delegating self-service automation requires cultural and platform changes for an organization. It can be helpful to think of these changes as an evolution. This image here outlines a journey through a digital operations maturity model for an IT automation developed by PagerDuty. The model describes characteristics of each maturity stage so businesses can assess where they are today and understand what the next phase looks like. The 5 phases include manual. In these organizations, automation can only be run by experts. There's a heavy reliance on ticketing systems, and subject matter experts usually push fixes to requests. And next would be reactive. At this stage, there is some general automation, but automation is still only initiated by experts. And these organizations also rely on ticketed escalations. Next up is responsive. As maturity develops, delegation of self-service operations improves. Here, there is some kind of runbook automation platform in use, and automation is delegated for common tasks rather than having to rely on a subject matter expert every time. And then finally, there's proactive. So we talk a lot about non-emergency use cases in this presentation, but the last phase of this maturity model is around event-driven automation. And in this phase, organizations are really reaping the benefits of better maturity as context-specific diagnostics and mitigation are automatically triggered when an incident hits. So deeper automation means frontline responders can not only diagnose, but can also resolve recurring issues without escalating to an expert via self-service. So getting a little bit more specific, here are a number of example automation tasks I often see organizations implement. So with the x-axis on the bottom here being the level of sophistication, meaning how complex is this task? Simple tasks have, one step without any options, whereas sophisticated ones have multiple steps, tools, and endpoints involved. And the y-axis here is the level of impact. High impact activities could break systems. No impact activities are, non-change activities. So on the bottom left, we have things like incident enrichment, essentially automatically collecting diagnostics and attaching them to a ticket that's tracking a production outage, for example. Relatively simple task that doesn't take too long to do manually and doesn't carry much risk since all it's doing is copying logs from one place to another. Although these sorts of tasks may not be very difficult or complex, they're often great candidates for automation if they occur really frequently. On the flip side here, we have rollback and redeploy. This is often a very complex operation that involves orchestrating, load balancers, web servers, and database, and has a very high impact to the business if things don't go as planned. So we often categorize these various tasks like this into a crawl, walk, run in terms of maturity. Starting out by crawling, we can often gain a lot of efficiency by automating relatively simple activities like health checks and incident enrichment while we get comfortable with the new platform. Walking involves taking things to the next level by automating more advanced tasks like performing service restarts. And running may involve even more complex maneuvers like doing config changes and rollbacks and redeploys. Once you have some use cases identified, the first step is to work with your subject matter experts to understand the workflows and codify them, right? What is it they're doing to fulfill these requests? What tools are they using? In what order? What scripts or commands are being used and what are their inputs, et cetera, et cetera. We usually want to extract all of the knowledge and experience from your subject matter experts so that are used to execute these workflows. The next step is to take this knowledge from your subject matter experts and codify it into self-service jobs. Now here at Rundeck, we help customers do this all the time. And our platform gives users essentially easy buttons that they can push as needed to run these jobs. Our platform makes your workflows more secure, auditable, and easier to run. And now next comes the fun part, giving your users access to these self-service operations. Let's take a look at just a quick before and after with a couple use cases. Over here on the left, we have our poor subject matter expert that's being inundated with all sorts of requests. And it's preventing her from working on stuff that matters. Once users can get things done for themselves, they get faster turnaround and she gets fewer interruptions. And that's a win-win. Another use case we can take a quick look at is incident response. So here we see Alice again responding to a PagerDuty alert, letting her know about a production outage. First, she has to manually collect and examine the logs. And she eventually realizes a service restart is needed. But since she doesn't have access to log into the system to do this herself, she needs to escalate and interrupt somebody else for help. With Rundeck connected to her incident response solution, logs can be automatically collected and attached to her incident as soon as it's created. And she can execute an automated Rundeck workflow that allows her to perform a service restart through PagerDuty, another major win for Alice. So now I'm going to hand the reins over to my teammate, Jake, who's going to take you through a quick demo here.
Thank you, Jesse. In this demo, we will show how a self-service mechanism for developers or other departments can take the burden off of site reliability and IT operations teams. Without this self-service mechanism, other teams have to open tickets or message channels to make requests of operations. This slows down productivity and interrupts operations teams from their high priority tasks. Rundeck changes this model by providing a simple and secure interface for other teams to conduct pre-approved tasks authored by engineering and operations. Let's look at a common example. Developers and, in fact, other teams regularly ask the operations team to provide a snapshot of production data that can be used for testing new code or analyzed for business operations, such as marketing analytics. Here in Rundeck, the user is presented with a simplified form to determine the behavior and desired outputs from the automation. In this case, I will choose to snapshot 1,000 rows from my database, deploy it into this resource group in Azure. I'll also install Apache and create a name for my new VM. And then we will execute. When the job is initiated, it actually initiates the snapshot of the database as well as the provisioning of the infrastructure in parallel. This significantly reduces the time to accomplish the full workflow and does not leave room for human error. To snapshot the database, Rundeck executes commands on the remote host and then uses the built-in Azure integration to push the .SQL backup to our storage container in Azure. We can see that new backup.SQL here as a blob storage item. As mentioned, Rundeck is simultaneously provisioning the new VM. This is also accomplished using the built-in Azure integration. And it's worth noting that you can have Rundeck integrate with multiple Azure subscriptions. Now, in order to upload the database snapshot to our newly provisioned VM, Rundeck needs to have an updated inventory of our VMs in Azure. To do this, Rundeck dynamically pulls VMs from our Azure, on-premise, and other cloud providers and lists them as nodes in our resource inventory. In our steps in our job, we can refresh that syncing with Azure so that we can connect to our newly provisioned VM. And we can see our new VM now listed as a node to be used in our Rundeck job. Then Rundeck will install the necessary services, in this case, MySQL and Apache, and configure them as intended by the operations engineer who authored this workflow. Then Rundeck pulls the SQL backup from Azure Storage and deploys it as a new database on our VM. Lastly, our job cleans up by removing the backup from blob storage and then previews the data from a table in our database. Our developers or other users can now connect to our new VM using Azure's Cloud Shell or SSH. In summary, this is one example of how Rundeck can reduce the workload on operations by providing a self-service mechanism for other people in the organization. Reach out to learn more about how Rundeck can help drive efficiency for teams managing on-premise or cloud environments.
So wanted to thank everybody for tuning in today, for taking some time to learn about how to make your Azure cloud operations more self-service. If you'd like to see more, you can get a more custom demo of Rundeck at the URL on the screen here. Thanks again, and hope to talk to you soon.
All right, so that was the end of part 1 of Day 3 Cloud Summit 2021. And here's a very important thing that I've dropped a URL in the comments that, okay, let me do it again. All right, so we end this live stream now, okay? We end this live stream and I want you all to click on this link that I've just dropped in the comments. So click on this link and move to the part 2 of Day 3. This live stream is going to end in just about a minute. So I request, and there will be a break of 30 minutes. So go ahead and grab your coffee, grab your tea, and we'll see you on this link. It's very important that you go ahead and please click on this link, and we will see you on the part 2 of Day 3. And if you're watching us on Azure Summit.live website, hold on for 5 minutes and we're going to update. Just refresh the website and you should be looking at the new chat and the video. Having said that, thank you so much to everyone joining. My name is Stephen Simon, and I'll see you in about 30 minutes.
Script Runner, the #1 for PowerShell management. We get it. You were hoping that PowerShell would save your day, but you figured out that it is not user-friendly for non-experienced colleagues. Managing the increased demand on IT is a growing challenge, and running scripts manually is still very time-consuming and complex. Welcome to Script Runner, the #1 for PowerShell management. Script Runner runs on PowerShell scripts. It combines everything you need to efficiently manage and automate your complex IT infrastructure. With Script Runner, you'll be able to make it easy for your team to perform administrative tasks without any knowledge of PowerShell, have a transparent overview on all PowerShell activities, and most importantly, free up your IT resources for more relevant tasks such as innovation and development. Download your free trial now and unlock the power of PowerShell.